Attention to all participants. Our event will start in 10 minutes. Attention to all participants. Our event will start in 5 minutes. Before we start, let me explain to all of you about our event's guideline.
First, access to the Zoom will be open 1 hour before the event starts. Second, it's not mandatory, but please include the InCoBIFS logo in your presentation. 3, download and use our virtual background. 4, wear office or formal attire. 5th, please, when listening to the lecture, except when asking questions. Next, during the Q&A session, if you have a question, the moderator will unmute to allow to speak. 7th, the presenters must turn on the camera during the presentation session. 8th, for the presenter, change your name to presentation number to name and affiliation. For general participants, change and affiliation. 10th, the moderator or co-moderator will remind you when the presentation time will end.
Assalamualaikum warahmatullahi wabarakatuh.
Good morning, ladies and gentlemen.
May I have your attention, please?
Our event is about to begin. I am Hangesa and my partner.
Raihan Ashwa.
We will be your master of ceremony today.
Don't forget to rename according to the specified format. Your Excellencies, Dean Faculty of Fisheries and Marine, Universitas Airlangga, Profesor Insinyur Muhammad Amin Alamsyah, MSI, PhD. The Honorable Vice Deans, Faculty of Fisheries and Marine, Universitas Airlangga.
The Honorable Chairman of this fourth InCoBIFS, Mr. Eka Saputra, SPI, MSI. The Honorable keynote speakers who are Professor Dr. Saibunisa Abdul Hayy, Dr. Kandis Sridhar, and Dr. Armin Winter. The Honorable invited speaker, which is Mr. Anur Ahadi Abdillah, SPI, MSI, PhD, and Mr. Heru Pramono, SPI and Biotech, PhD, and all the moderators and the audiences.
Welcome to the fourth International Conference on Biotechnology and Food Science 2023, held by Faculty Fisheries and Marine, Universitas Airlangga, Surabaya. Ladies and gentlemen, before we officially open this event, may I request all of you to please turn on your camera and give a round of silence while the Indonesian national anthem is being played, followed by the singing of Hymn Airlangga.
The next one is the singing of Hymn Airlangga. For this specific reason, we generally ask you to put your right fist in your left chest. Thank you, ladies and gentlemen, for your participation.
Ladies and gentlemen, we are going to read the agenda for today's event. First, we have the welcoming remarks and the opening ceremony.
Second, we have a keynote speeches, and then we have a break time and poster session.
After the break, we will have oral presentation, which will be divided into two groups. Fifth, we have a wording session.
And last, we have closing remark by our third Vice Dean, Dr. Sabdan Riono.
Ladies and gentlemen, let's step to our next agenda. We would like to invite Mr. Eka Saputra, SPIMSI, who is the chairman of the 4th International Conference on Biotechnology and Food Science 2023, to deliver his speech. Mr. Eka, time is yours.
Okay, thank you, MC. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. The Honorable, our invited keynote speaker of today's conference, the Honorable of Dean and Vice Dean in the Faculty of Fisheries and Marine, Universitas Airlangga, Excellency, all fellows attending this conference. Good morning to all of you. Today we are very delightful to attend this annual conference named International Conference on Biotechnology and Food Science. I would like to say thanks for all participants to this conference. My name is Eka Saputra. I am a chief of organizing committee of this conference. Would like to present some points. We would like to acknowledge to our excellent University of Universitas Airlangga, especially Faculty of Fisheries and Marine, who have supported this conference. This conference was well organized by our team consisting of leaders, lecturers, supporting staffs, and students. We work hard to make this conference enjoyable and for sure excellent. For your information, the conference was attended virtually by 100 participants from some foreign countries such as Austria, Taiwan, Malaysia, and French. Last but not least, I would like to emphasize again, your submitted paper for this conference would be selectively published in the IOP conference proceeding or scientific journal, which are Scopus Index. I think that what I could speak to you today in this session. Please let us know if you have any technical problems during the conference. Again, thanks to all participants supporting this conference and for sure making this conference successful. See you and all the best. Thank you.
Thank you so much, Mr. Eka Saputra, for the warm speech.
Now, we would like to invite Professor Muhammad Amin Alamsyah, the Dean Faculty of Fisheries and Marine, Universitas Airlangga, to deliver a remark to officially open the 4th International Conference on Biotechnology and Food Science 2023. To Professor Amin Alamsyah, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Greeting from Faculty of Fisheries and Marine, Universitas Airlangga, Surabaya, Indonesia. I am Muhammad Amin Alamsyah, the Dean of Faculty of Fisheries and Marine, Universitas Airlangga, would like to say grateful thanks to all the keynote speakers, invited speakers, all the participants, and all the committee of the 4th International Conference on Biotechnology and Food Sciences 2023. I'm very happy to welcome of you in our beloved Faculty of Fisheries and Marine, Universitas Airlangga. We would like to know that the better nutrition must be provided in order to tackle the malnutrition problems faced by many countries, where aquatic organisms provide essential nutrients with significantly health benefits such as fish, mollusks, micro and macroalgae, coral reef, and other aquatic plants. Furthermore, many studies investigated the efficacy of compounds extracted from aquatic organisms such as fatty acid, protein, carbohydrates, pigments, and other small bioactive compounds and contributing to human health. The conference aims to communicate the result of research and innovation in basic and applied sciences, especially in fish biotechnology products, fishery product quality, nutrition science, energy, as well as the food diet. and then each sector is expected to share with each other and will generate future collaborative activities. In the future, as currently we are encouraged to implement quadruple helix that composing of academic, business, government and societies. This is all for me and hope you could enjoy this conference. Finally, in the name of our God, most gracious and merciful, I would like to open the 4th International Conference on Biotechnology and Food Sciences 2023 officially. Thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor, for the wonderful speech.
Ladies and gentlemen, we are going to the next agenda, which is a keynote session. Today, we are very pleased to welcome our distinguished keynote speakers, namely Professor Dr. Saibunisa Abdul Hai, Dr. Candice Hidar, and Dr. Armin Winter. And the moderator for today's discussion will be Mr. Anur Ahadi Abdullah, SPIMSI, PhD.
For the first moderator on the first discussion today is Mr. Anur Ahadi Abdullah, SBI MSI PhD. For Mr. Anur, time is yours.
Thank you, Haisa. Is my sound is clear?
The sound is clear, sir.
Okay, thank you. Thank you for having me. Good morning, ladies and gentlemen. Welcome to first section for keynote speech. I'm Hadi. I will, as moderator in here, my pleasure to be moderator for this session. First of all, before this session is beginning, let me briefly introduce to our keynote speaker. Our keynote speaker is Professor Dr. Saibunisa Abdul Hai. She's from Faculty of Applied Science, University Technology, Mara, Malaysia. For the biography is she graduated with PhD degree, Doctor of Philosophy in Food Science from University Kebangsaan Malaysia, and she's expertise in extraction, stabilization technology, and another is phytochemistry, analytical chemistry, and environmental chemistry. She has its index in Scopus is 12, and also its index in Google Scholar is 15. Today, she will share about extraction, encapsulation, and characterization of catfish, Clarias batrachus, waste fish oil. She will deliver or share around 40 minutes, and after that we will continue with Q&A. So for the audience, if you have a question, you can type in the message. I will make a list, or you can directly ask to Prof. Saibunisa after the end of the presentations. Ladies and gentlemen, please give warm welcome to Prof. Dr. Saibunisa Abdul Hai. Hello, Professor.
Hello, Saiko. Hello.
Hello, yeah, we can hear you, Professor.
Okay, all right, okay.
So you have 40 minutes to deliver your topic, and after that we have a Q&A around 10 minutes. So time is yours, Professor.
All right, thank you so much, Dr. Anur. Yeah, okay. Yeah, before anyone sharing my slide? the secretariat?
Maybe they will still prepare, Prof.
Oh, they still prepare. All right. Anyway,
How about in Malaysia? Before that, in Malaysia, is rainy season or hot condition?
yeah, the season in Malaysia is a mixture. It's hot in the morning and then in the evening. In Shah Alam especially, it's raining after 3 o'clock. It's raining. So yeah, it's quite both actually raining and also hot in Malaysia. So yeah, and thank you so much for the organizer for inviting me for this session. It's my pleasure to share my area on extraction and stabilization actually. So okay, so I was also informed this conference actually InCoBIFS, right?
Yeah.
InCoBIF, yeah, the International Conference on Biotechnology and Fisheries, right?
Yes.
Annually been conducted by UNAIR, right?
Mm.
Universitas Airlangga. So especially for the faculty of Fisheries and Marine, right?
Marine.
Marine. Yeah, okay,
Marine.
handled by Marine. So it's good platform actually for sharing. It's very specific actually for fisheries and marine. So I will also share a slide on that, and hopefully will be benefit for the audience that will be with us for this session this morning.
Okay. Sorry, Prof. You will share by yourself or you can share by.
Yeah, I sent to the secretariat to share. Is it possible?
Or if possible, you can share from your side, Prof. Is possible? Wait a minute, Prof. We will contact the secretary, Prof. Maybe for waiting, maybe I will ask some question for you, Prof. This will be made with my expertise, Prof. It's about you will present about the micro encapsulation, right, Prof? Okay. I think, hello, Prof. Prof. Zaibuniza. Okay, Prof. Zaibuniza, you can see your PPT. Maybe your mic is mute, Prof. Can you unmute your mic? Yeah. Okay.
Okay, yeah,
Okay. Time is here, Prof.
All right. Okay. Assalamualaikum warahmatullahi wabarakatuh to the secretariat of the conference. Thank you very much for inviting me and also the deans of the faculty and also all the top management, students, lecturers, professors, and delegates that joined the conference for this morning. Alhamdulillah, thank you so much for this opportunity for me to share with UNAIR, the students and staff, on this topic, which is actually, I try to relate to the theme of the conference, the role of sustainable fisheries product technology in ensuring zero hunger for sustainable development. So I'm touching on the fish oil, which are from the waste, viscera oil, and also from a low-cost fish in Malaysia, catfish. Okay, catfish is considered as a low-cost fish in Malaysia. So, and also from the waste, if you extract the oil, so it can be a good sustainable nutrient oil for human consumption, right? So that's why I focus on the extraction and also encapsulation and characterization of catfish from the waste viscera oil, right? All right. Okay, my name is Zaibunisa Abdul Hayy. I'm from Universitas Technology Mara, Malaysia. And that's my contact number and email. If you have any question, you can also ask me through that. All right. Okay, next slide, please. Okay, this is my presentation outline. I will start with a little bit introduction about catfish and also what are the objectives of this particular study and what are the methods and materials that we use for this study, and some result and discussion related to fish oil, especially waste fish oil extraction, and some conclusion that we will draw from this study, right? Okay, next slide, please. Okay, so when you talk about fish is very nutritious product, high in polyunsaturated fatty acid or PUFA, such as AA and also DHA, right? So it's a very nutritious oil, which is good for cardiovascular disease, okay, if you consume every day. So the objective of this study is to find alternative source. Instead of using the flesh, which we consume every day, we are using the waste of the fish to extract the oil, right? And use it as also beneficial for human consumption. Okay, the importance of PUFA in human health and nutrition is well recognized in preventing cardiovascular disease, Alzheimer, and also psoriasis, right? So this is the key point why we have to extract the oil, or we consume fish oil. Okay, fish oil can be extracted from the flesh as well from the viscera of marine fish, such as salmon, herring, and codfish. However, marine fish are usually more expensive and not easily available. Okay, so yeah, I'm talking about Malaysian spectra. Marine fish usually more expensive than freshwater fish. Okay, and especially catfish is considered as a cheap source of fish. Okay, so that's why the study focuses on catfish, especially this species Clarias batracis, which is also known as walking catfish, right? Walking catfish in Malaysia. Atau di Malaysia kita juga dikenali sebagai ikan keli, right? So I don't know what you call in Indonesia. Kalau di Malaysia, we call it ikan keli. All right, next slide, please. Okay, so as I mentioned, this is how the walking catfish, Clarias batracis, looks like. Okay, not many people consume this fish in Malaysia, but it's easily available, right? So that's why this study focuses on the cheap price fish, food fish, sourced from walking catfish, which is a cheap source of fish. And a great attention is now being paid for popularization of fish in mass culture. So when people start consuming it, it's more, a lot of people are actually culturing the fish, all right? Every year, considerable amount of total catch is discarded as processing leftovers. So when you're consuming catfish or you have any other processing that you're doing with catfish, the waste is always leftovers, especially the fins, frame, head, skin, and viscera. So annual discard of this to be about 25% of the total production. So it's a waste, the fresh fish. Okay, and it's known that most of the oil in catfish is actually found in the viscera, right? So the viscera contain more oil compared to the flesh, so which is the one that we actually discarded. So it contains about 33% of fats and other lipids, which could be beneficial for human health, right? So that is a bit introduction on catfish. I'm sure all the audience also, and it's quite popular, I think, here in Indonesia, consumption of catfish, right? Okay, next slide, please. So this is just some different species of catfish, okay, and also what are the what you call that, the scientific name for it, right? So if you see, you have various matrices or working catfish, which is used in this study, but I just want to highlight they have other species as well on catfish. So the way it looks also different. Okay, so probably Indonesia maybe consume other fish as well, but we are quite common with the walking catfish, right? So this is just to show the scenario of catfish. Not only one species, you have other species as well. All right, okay, next slide, please. Okay, the objective of this study actually to effect of different extraction method of catfish oil on the yield with a higher efficiency, right? So I'll focus in this study on the extraction method. Okay, so a few extraction method will be covered to show that fish oil can be extracted, the conventional method and also the more advanced method, right? So you can see the difference between the different extraction method, and also to stabilize the oil. Okay, we actually make it into powdered form. When we call powdered form, we call it inclusion complex. Okay, so what happened is during the encapsulation, you have a host and also you have the oil. The host that we use is cyclodextrin to encapsulate the oil. Right, when you encapsulate, you form in the form of a powder. So the advantage of encapsulation is you can extend the shelf life of the oil, and also you can control the rancidity. And also when you apply back in food, it will be more soluble. Okay, so oil, when you apply in food, usually there's separation, but in the encapsulated form, it can dissolve to a certain level in your food. All right, and also it can, as I said just now, extend the shelf life because rancidity always a problem with fish oil. Okay, so in characterization of the inclusion complex we carry out using DSC, FTIR, and FISM. Okay, so to ensure the inclusion has been formed, right? So that is the objective of this study. Okay, next slide, please. All right, how we prepare the sample, the fresh catfish, we wash under running tap water and we ground using a commercial blinder for 10 minutes, stored at -20, used for analysis. So before we use for extraction, we freeze dry it for 5 days. And then once it's dried, we keep it in the ground and place in an airtight glass bottle and kept in a freezer for -20 until needed for extraction. Okay, that's how we prepare our catfish. So so what we do, we just have the viscera, and we ground it and freeze dried it and keep it for extraction process. Okay, next slide, please. Okay, this is the extraction method that we use. We use wet rendering method, which is a conventional method. And then we use oxalate extraction. And also we compare with pressurized liquid extraction, or we call it PLE. Okay, this is a more modern method of extraction. Okay, we also have in UITM, not only PLE, we also have supercritical fluid extraction and also ultrasonic assisted extraction. Okay, so all these extraction method have their pros and cons. Okay, but in this study, this particular study, we did these 3 methods to compare. But I also can talk about the other methods of extraction. Okay, next slide, please. All right, this is how we do the wet rendering, which is the conventional method. Okay, samples were boiled. Okay, with a sample white ratio of 1:2 in glass beaker for 40 minutes. And we press to squeeze out the liquid phase of the water and oil. And we've centrifuged to remove the suspended solid, and the fat layer of oil was removed using the separator funnel. Okay, so that's how a conventional method of, we call it wet rendering. Okay, so we get the oil from using wet rendering method. Okay, the next one. Next slide, please. All right, this is oxalate extraction method. whereby we put the sample, 10-gram dry weight of ground catfish viscera with 50 ml of N-hexane for 8 hours. So it will extract, of course, with the hexane, we will extract the oil, okay, the fish oil. So once you get it, you condense and then you get the oil, and the oil is already available. So this is another method of extraction using source fluid extraction method. Okay, the next one is the one that I want to highlight, which is actually known as accelerated solvent extraction method. Next slide, please. Okay, this is equipment we have in UITM. We call it accelerated solvent extractor. Okay, the beauty of this extraction is they're using high pressure and temperature. So when you use high pressure and also temperature, you can extract more of the oil out, right? And also this equipment, you can actually optimize the right temperature and time and also pressure needed to extract the oil that you want, the composition of the oil that you want. If you want more of the EPA, actually modify and get the optimal condition. And if you see the cell also, you have different cell size. You have 250 and also you have 150 ml cell. And we also have a bigger unit that can cover the higher volume. But in this study, we use the laboratory scale extractor. Okay, and this extractor is connected to solvent vials, bottles. What we can do with this extractor, you can actually combine different solvent if you want for your study. Okay, for example, you can mix water and ethanol together. Okay, or combination of two solvents, water and or and a different method can be used, whatever solvent that you want. Okay, sorry. Okay, this equipment, you can call it PLE, pressurized liquid extraction, or accelerated solvent extractor. Both the same. Certain publication, they use ACE, accelerated solvent extractor. Certain publication, they use PLE, pressurized liquid extraction. But it's both are referring to the same equipment. Okay, how we do extract the fish oil is we use 3 grams of dried sample with 2 grams of diatomous earth. You have to mix together. Okay, the function of DE, diatomous earth, is to make sure when your dry sample put in the system, when there is high pressure, it won't compress your sample. Okay, so it will give some what do you call that, space for oil to come out when you put in what do you call that, nitrogen to flush it out. All right, so if you using without the DE, the sample will compress and you will block the system, right? So that's why sample have to be mixed with DE and placed in the 22 ml cell with cellulose filter. Okay, why you need cellulose filter is to filter out. So the oil that you get is already filtered. You don't have to do separate filtration outside. Okay, so it's all 2 in 1. The other thing about this method is you can also do cleanup. Okay, for example, we also have done that technique whereby in the cell you can put activated carbon, or you can put silica, or you can put bentonite clay as a cleanup agent in the cell. So when you extract, you can actually optimize the amount of bentonite clay or activated carbon to clean up your oil. That one also can be done, right? Okay, so once you have filled up your cell with your filter paper with the DE together at the bottom of the cell, you close it, and then samples are ready for extraction. In this study, we use non-polar solvent and hexane. And the operating condition for this extract is pressure, temperature, and the static time. Okay, so static time means when the solvent come into your cell, the solvent and cell will remain static for some time. Okay, even that will affect your extraction quality. So you can also optimize that. Okay, so the longer maybe it's good, or a certain time period is that is the maximum time that you need. Above that is already saturated. So you can optimum in that parameter as well. And then you do, of course, RSM using central composite design. The extract that you get, straight away you can rotary evaporate to remove your solvent, and the extracted oil is in the form of fish oil. Okay. All right, next slide, please. Okay, this is how the pressurized liquid extraction looks like. As I said, you have the extraction cell, okay, sample and dispersal in the cell. Okay, when you put in, you have solvent and you have pump. And your extraction cell is already in the oven to control your temperature. And the system is also controlled with pressure. So you can modify whatever temperature, pressure, and your static time that you want in the system. And you have nitrogen to purge your solvent into the cell with the pump. And the solvent, you have different vials. You can see different bottles. So you can mix the solvent. You can use only one solvent, or you can have a mixture of 3 solvents to see which is the best extracting solvent for your sample. And once it's done, you can see the collection vial, the oil can be collected. So this is the method that we use. Of course, as I mentioned just now, we also have supercritical fluid extraction, which can produce more premium oil. But I'm not touching on SFE in this study, in this presentation. But we also have that in ultrasonic assisted extraction. Okay. Next slide, please. Okay, so when we get the oil, we all the 3 methods just now: wet rendering, saucelette, and also the pressurized liquid extraction. We microencapsulate using beta-cyclodextrin, and using a few methods. One is kneading method, co-precipitation method, and also the control is physical mixture. Why we need physical mixture is to actually see whether the actual kneading and co-precipitation really work. Physical mixture is just you just mix the 2 components together, okay, as a control. So the kneading method and co-precipitation method, we want to see if there is any effect or not. All right, and the ratio also have to be optimized. Okay, so in this study, 1 to 8 BCD, 1 oil, 8 of BCD was optimized, and that is the best result for our encapsulation study. All right, next slide, please. Okay, this is how we characterize the encapsulation. All right, we use differential scanning colorimeter to see if there is thermal effect on the inclusion complex. And also molecular level, we use FTIR to see if there is any difference between the encapsulated sample and the unencapsulated sample. And also morphological study using field emission scan electron microscopy using FSM. All right, so these 3 methods been used for characterization of this study. All right, next slide, please. Next slide, please. All right, so in terms of RSM, we actually using 5-level extraction, the central composite design being used, and so we have the extraction time is between 4.9 to 20, pressure between 999 is more or less about 1,000 to 2,500, and also temperature about 39.7 to 110 temperature. right? So the three independent variables, temperature, pressure, and set times, and the response are based on oil yield, EPA, and also DHA were determined using RSM. Okay, so the variables and the response are three for both. Okay, and next slide, please. So the ANOVA results that we obtain is EPA and DHA. We get a linear effect, and also the yield in the form of quadratic. So yeah, that's the equation, the modeling equation. Temperature is the one that, according to the model, is the one that significantly affect the extraction, okay, from this study. So we focus on the temperature. All right, okay, next slide, please. So this is the whole overall CCD and the result that we obtain. Okay, so with the predicted equation and also the optimized parameter for the extraction based on the RSM just now is 17 minutes, a pressure of 2198, and also temperature of 96 degrees Celsius, which we managed to get the oil yield of 83.66% dry weight basis. All right, so it's quite high, the yield using PLE as the method of extraction for this oil extraction. All right, next slide, please. Okay, so this is the overall result that we obtained. So you can see that the oil yield is very high in PLE and also EPA and DHA, right? So in comparison, you can have rendering also some EPA are quite high in the normal conventional method. In our study, we managed to get oil yield high and also equally high in EPA and DHA compared to the conventional method. All right, but Saucelet method, even though the oil yield is quite high, but the EPA is significantly low. All right, because maybe the high temperature for the extraction. Okay, so that is overall in terms of extraction. So you have pros and cons in the extraction, different extraction, different unique method, and you see which one is that you prefer. If you want the oil yield is high, you can go for PLE and Saucelet. If you want in terms of EPA is high and also DHA high, PLE is of course is showing a good method where you have a balance of both EPA and DHA and also oil yield. All right, next slide, please. So this is how the oil from the PLE looks like. Okay, when you extract it out, yellow with desirable fishy smell of the fish, right? So you can actually further, we have done study also to remove the color, okay, of the oil. If you want a more desirable lighter color, you can use activated carbon in a cleanup cell to produce a lighter color of oil. But at the same time, we can monitor using heavy metal. If there is any heavy metal being bleached out as well when you clean up with the activated carbon. All right. Okay. Next slide, please. Okay, so in terms of characterization, we see the melting temperature. Okay, you see there is some difference between the co-precipitation method. The melting temperature looks different compared to the E is catfish oil. You can see there's no melting temperature at that particular range, and cyclodextrin, you have melting temperature and slightly lower temperature. But when you encapsulate with this oil, you can see some drift in the melting temperature to higher temperature. And you can see that one is very obvious in co-precipitation method. All right, so that shows that some inclusion complex already formed. Whereas if you see the physical mixture, it's more or less similar to beta-cyclodextrin. All right, so that one is showing no interaction happening. Right, so it has similar properties to beta-cyclodextrin. Okay, when you have co-precipitation, there is a drift in the melting temperature. All right, okay, next one, please. So the data you can see the peak and also the onset and the onset from the DSC results, so indicating the same thing. There is a shift to melting point to high temperature. For co-precipitation method, that indicates inclusion complex is happening or already fully happened in co-precipitation method. So when it's fully happened, that means you're already protecting your oil with cyclodextrin. Okay, next slide, please. Okay, this is the more molecular level to see in terms of the bond that presence in our sample and also in the control and also in the host and oil. So when we see this again, the catfish oil as the first one, A is a catfish oil, B is the kneading method. Okay, okay, the difference between co-precipitation method and the kneading method. Kneading is more a crude method of forming inclusion complex, whereas co-precipitation is a more unique method and more complete method. So you want to know between the three samples, between kneading and co-precipitation, which is the better method, and physical mixture is always as a control. All right, so you can also see here the D, the co-precipitation method. Some peaks are disappeared, especially carbonyl disappeared in the co-precipitation method. That indicates full inclusion complex is already formed, and that particular bond is already disappeared after the new inclusion complex formed. Right? So that indication some interaction already happened between cyclodextrin and also our oil, right? So a new solid phase has already been formed. Whereas in the kneading method and so the physical mixture, you can still appear, okay? Right, that indicates that it happened, is weakened, but it's not completely gone. The other peaks, you can see some shift and also some CH, the intensity will decrease or some are increased, some shift. So that shows some molecular level of interaction already happened in between the oil and also cyclodextrin. Okay, next slide, please. Okay, so in terms of morphological study, all right, this is actually how it looks like. Okay, so when you see the morphology of the sample, the A is actually the cyclodextrin, B is co-precipitation, C is kneading, and also D is physical mixture. So cyclodextrin alone, it looks like more dry, but when you see D is physical mixture, you can see the oil actually surrounded the cyclodextrin. So it looks like clump or agglomerates, right? When you see that the physical mixture is just the oil on top of cyclodextrin, you can clearly see that between A and D. Whereas the C also, which is kneading method, also resembling like D, but is slightly better than D. Okay, it doesn't look so much of like a clump, but it's slightly looks drier. And the one B you can see is totally different from the original cyclodextrin morphology. So you can see it's a different characteristic than the cyclodextrin by itself. So that indicates a new solid phase already been formed, whereas D is just a control. You can see oil is just on top of your cyclodextrin. So that is another indication of inclusion complex being formed, right? So that is on the FASM study. Okay, next one, please. Okay, so this is to show that when you compare between conventional extraction method, the optimized PLE provide higher extraction efficiency, and the optimal condition from this study is about 17 minutes, 96 degree and 2196 psi. And oil yield was quite high, 83.66 from the viscera. So it can be actually applied to industry using this method. And in terms of characterization with cyclodextrin of the oil, you can see the 3 different methods being used and 3 different characterization being applied. And that also indicating co-precipitation is a better method of extraction. You can see clearly the thermal shift is better in co-precipitation method. FTIR, disappearance of carbonyl group, and also FASM morphologically, you can see it's a different new solid phase being formed. All right, so from this study, we can conclude that, of course, further study can be carried out. And also we have done some other studies as well. But from this scope of this presentation, we cover until this. So it can be producing odorless catfish oil powder from cheap source. So another thing is when you convert into a powder, the odor also significantly reduce in the form of powder. So that also another advantage, and also easier handling compared to oil. All right. To form loose interaction, kneading and physical mixture loose interaction, whereas co-precipitation was the chosen method for the potential future study from this research. All right, with that, I end my presentation. I would like to open if there is any Q&A session, we can have a discussion. Thank you.
Thank you very much, Dr. Zaibunisa. It's very, very interesting for me. It's because actually I do some research in microencapsulation too, using the tuna fish oil.
All
So
right.
for the technique, I think I use the tuna fish oil, but using the waste is kind of interesting because sometimes we just eat the fish, but not all will be waste like that. Okay.
Yes, yes. So the waste can be a good, if you can convert into oil, will be a good source for oil, EPA and DHA as well.
Yeah, interesting, because like every day I almost consume fish oil, doctor.
All right,
I'm
okay.
crazy about the fish oil. Okay, we move to Q&A. Maybe any question for the audience, especially if your background about the fish processing is kind of interesting topic. You can explore the waste from the fish product and anything. Any questions? You can raise your hand or okay, maybe the need chat. In the chat we don't have. Okay, maybe I will ask first, Prof, to stimulate the audience. I do experiment using the tuna fish oil, and especially for the microencapsulation, Prof. And I see you using the beta cyclodextrin, right, Prof?
Yes.
I'm using maltodextrin. Yeah, maltodextrin, and also using arustat, using the starch, Prof. I want to ask, do you use what kind of the drying method to making powder from the liquid, from the emulsion? Using spray dry or fresh dry?
The one that we use is actually cabinet drying. After the inclusion complex, we dry it, and after that, we blend it if needed to make into powder. All right, so we target to make it a simpler form so that we can commercialize this product. Okay, so at the moment we are using, of course, you can also use freeze drying if you want, but the cabinet drying works well for us.
Okay. How about the moisture content? Still high or lower, Prof, for after drying, Prof?
Yeah, it's already low because we don't use any when you do inclusion complex, of course there is some moisture there. It's already below 15 to 10, yeah, moisture content.
Okay. Any question for others audience?
Excuse me, I have one question.
Okay, Ms. Balkis, you can deliver your question.
Okay, thank you, Prof, for the very interesting explanation. I have a question about what the types or species of catfish that like Clarias caribenus, Clarias insolitus, and other, this affect the content of the main component to be made into the fishery oil. Do other species also have a good potential to be made into fishery oil with a better composition? Thank you.
Okay, as I mentioned just in my slide, I use Clarias petrasus as my species, which is known as walking catfish in Malaysia. All right, and you can also use other species if you want for your study because all equally are good. Catfish, the species itself is very high in oil. So any other species available in Indonesia, you can try. So all with the waste, of course, is higher fish oil content in the waste, in the viscera. So the same study can be carried out in other species as well.
Is that clear, Balkis?
Yes, that's enough to answer, Prof. Thank you, Prof, for the explanation.
Thank you.
Thank you, Balkis. Maybe another audience. Oh, there are possibility. Oh, this from they have question from Raihan, bro. To Raihan, you want to ask directly or I want enough? I read your questions, Raihan. Okay, maybe I will read the Raihan question. Good morning, Prof. Zebunisa. My name is Raihan. You want to ask, are there any special guideline for choosing high quality fish oil supplement or on the market? Maybe like general question.
As I mentioned in my slide, the character parameter that we use are EPA and DHA. All right, so that should be a quality parameter for fish oil. All right, if it's high, then that is the one that benefit as a good fat for human consumption. Right, so focus on that EPA and DHA. That is the one that can give indicates quality. Of course, the order also some people are not so favorable for the order. Okay, because that's why it's always in the form of capsule. Okay, so you can't really smell the oil when you consume. Okay, so that if you're tolerable for that, you can go for that. If you can't, then this is maybe another option. So you have very bad cough. Sorry. So if you're not able to tolerate the order, then go for the normal one with the capsule. That should be okay.
Okay. Another question from the summer course. Thank you, Mr. Raihan. Okay, another question. Yeah.
I'm Azlin. I'm joining this summer class actually.
Yes.
I'm Azlin from UITM.
Okay.
Yeah, doctor. I think your research is very interesting. I have two questions. The first one, have you run the sensory test for the product? And the second question, why you choose to produce the powder form instead of liquid encapsulated?
Sorry, I can't really get the question just now. Because maybe Dr. Anur, can you get the question?
The first question is, did you conduct the sensory test, doctor?
Oh, okay, all right. Sensory. Okay. Yeah, we have done sensory more into the aroma oil. Okay, the oil. So we have compared between the oil and also the encapsulated. So result indicates the encapsulated, the odor is significantly reduced. So you don't really smell it. Okay, but in the oil, if in the form of oil, yes, as I mentioned, it will be very fishy smell. But if you encapsulate in the form of capsule, okay, oil in the capsule, yeah, it's tolerable to consume. So we have done sensory. in terms of smell. Yes.
Okay. For the second questions, it's not clear for us to, yeah.
Why do they choose to produce in powder form instead of liquid encapsulated fish oil?
Okay.
Why powder form?
Oh, why powder form?
Yeah.
Okay, why powder form? There's many reasons why we convert into powder form. As I mentioned, we want to reduce the odor, okay, so that it's not smelly. When you want to consume it, okay. So that's one reason. The other one is encapsulated. Usually, it's more stable. The oil is stable, controlled from rancidity, so extend the shelf life. So that's why we try to encapsulate and see whether the extension of the shelf life. Yes, it's in other studies have shown the EPA DHA more stable in the form of encapsulated. Okay, whereas in the oil is prone for oxidation. Okay, prone for oxidation and can reduce the shelf life. And also it's easier for to carry and all that in the form of powder, right? So it's easier handling. So that's the reason we propose this method of encapsulation, convert into powder form. Thank you.
So it's dry is better, right?
Yeah.
Another questions? You can also type in the chat room. So actually, there are many audience in food processing, bro. So like maybe some student or some audience knew about the RSMs, but for me, it's new is PLE. This like kind of the for the extraction, and I see is this better than another method, right, bro? The quality and the quantity give a little bit.
Yes. Is the extraction efficiency improve significantly when you use PLE because you are doing it in a controlled condition. Not only fish, we have tried extraction with the other herbs as well, like turmeric, lemongrass. You can produce premium quality of oil with PLE, right? And also we compare with SFE, supercritical fluid extraction. Okay, this is another area that probably we can also venture where you don't use any solvent at all, so it's really good for the environment, right? Yeah, we have SFE also in our university for extraction.
Okay. One question from me. How about the cost, bro? Compared with the problem is cost.
Yes. There's always premium product will be higher in quality and higher in the cost. So if you're selling your product at a higher price for premium product, then PLE will be good. If you targeting your audience, the normal audience, which they can't afford premium quality product, then we better use the normal conventional method rendering, right? But this product is slightly higher in cost, but you get a better quality product. And also it's easier to handle and extract.
Okay, other questions?
Excuse me,
Yes.
Oh, okay. Sonia, Miss Sonia.
Yes. Thank you for allowing me to ask a question. Good morning, Professor Devinisa and Mr. Anahari. First of all, thank you very much for being here with us. Let me introduce myself. I am Sonia with final name number 123 from Fisheries Biotechnology major, Faculty of Fisheries and Marine, Universitas Airlangga, Surabaya. I would like to ask you a question. For reading about extraction, how to optimize extraction even with limited resource.
Okay. How to optimize? Oh, thank you for the question. How to optimize extraction using limited resources, right? That's the question.
Right, Prof.
Okay, with limited resources, I always advise to use the wet rendering method. Wet rendering, without using any solvent, you just use water. Okay, you just use water, you boil your fish until you get your oil, and then you centrifuge to separate the oil. So that is the basic method. You still can extract with limited resources. And of course, saucelet is another cheaper method. Saucelet is another cheaper method. You also have methods like hydrodistillation and steam distillation. There's also another option, hydrodistillation and steam distillation. We only use water. There's another cheap source of extraction, but we didn't cover in this study, steam distillation and hydrodistillation. That's another cheap source of extraction. So in the industry, they're using this method. But for fish, usually the wet rendering method being used. It's a very cheap. You can, I think no issues on equipments or facilities. Extraction can be done using limited resources.
Is clear, Ms. Balkis? You get it?
Yeah, again, Mr. and Ima, for me. Thank you for the explanation, Prof. Lisa. See you the next time. Thank you.
Thank you.
Ms. Balkis. Another question, Prof. Maybe one or two more questions. This from Mr. Muhammad. My name Muhammad. He asked about, are there special factors that need to be considered in maintain the solubility of active compound in catfish encapsulation? I think more close how to maintain the stability, bro. Maybe from the rancidity or solubility like that.
Yeah, you can also investigate solubility. You call it solubility study. Right? If you are looking into solubility, yes, some of the compound weren't soluble. So we have done some studies also on solubility study. You put back and see how much of your compound soluble in the water, and you extract out and you see how much is soluble. So that study you can use to see whether it can actually improve the solubility of your compound needed. But definitely, if you put oil and you put our inclusion complex will have better solubility. In terms of stability, as I mentioned, because it's encapsulated and it's already in a different form, when you put water, cyclodextrin outside the host will soluble, of course, because it's hydrophilic, and the hydrophobic oil will be released. Right, that's why it can be good form of encapsulation, because cyclodextrins always have a hole inside which is hydrophobic, so oil will be trapped inside. So that stabilize the system and make it form into liquid form. So when you put in water back with a certain temperature, it will dissolve and you get back your compound. So that's how it works with cyclodextrin.
Okay. You get it, Mr. Muhammad? Yeah. Maybe last question, bro. Maybe from me. Is there any chance to collaborate, Prof?
Yes. Yes. I really welcome delegates or researchers from Airlangga in terms of fish studies. You are from the faculty, right, Dr. Anu?
Yeah, I come from the faculty. Yeah.
Faculty, yes. Yeah, we can collaborate in terms of our extraction that we have in our university. We can compare fish oil, whatever species that you want to investigate, and also in terms of characterization and encapsulation of the oil if needed, or any other research that I really want to collaborate with UNAIR.
Yeah, it's nice, bro, because I'm really doing about the micro encapsulation and doing the characterization like oxidation, stability, and SEM, and also T-bars, using T-bars like that. Okay,
All
last
right.
question. Did you characterize the oxidation stability, bro, for your product?
Oxidation stability in terms of rancidity?
Yeah, rancidity, yeah.
Yes. Yeah. We have done some rancimate analysis to show that during storage, is there any changes in the rancidity? Yes, it's improved. With Of course, fish oil by itself is very easy for oxidation. So with cyclodextrin, it reduces the period for rancidity to happen.
Yes. Okay, thank you. Maybe the time is over. Thank you so much for your give a lecture for us, and it will give a more like insight about the how to process the waste material, and especially we can get the pure compound with the more high value like oil. Thank you, Dr. Zebunisa. We will send our certificate to you directly by emails. Thank you. Hopefully you can join until this conference ends. Thank you so much. I hope we can collaborate in the future. I will contact you directly later. Thank you. This is the end of the first session. Thank you for the Prof. Zaibunisa. We will meet you in another times. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you so much for the organizer, and also I think Dr. Dwi that gonna communicate with me. Thank you so much, Dr. Dwi. But I have to leave the conference because I have another meeting to join. So again, thank you for the opportunity. I'm very glad to be part of this conference, and hope we can collaborate in other platform. Thank you so much.
Thank you.
Thank you, Prof.
Yes.
Yeah.
I give back to Master of Ceremony. Thank you.
Yeah, thank you very much for our wonderful keynote speakers and moderator, Professor Dr. Zaibunisa and Mr. Hadi.
Before we start to the next keynote, we would like to greet our honorable keynote and invited speaker who already joined. Move to the next agenda. The second and last keynote will be moderated by Mr. Muhammad Nur Goyatul Amin, STP, MPMSC, who is a full-time lecturer and researcher in the Department of Marine, Faculty of Fisheries and Marine, Universitas Airlangga. Currently, Mr. Goyatul doing a PhD in food chemistry at Boku University, Austria. He was dealing with fucoidan, a marine sulfated polysaccharide. Is Mr. Goyatul already joined with us?
Hello, good morning, Miss Raisnawa. Yeah, I have already connected with you. Can you hear me?
Yes, I can hear you clearly. Okay, thank you, Mr. Goyatul. I will give the present with you. Time is yours.
Okay, thank you very much. All right, thank you very much, Master of Ceremony, who give me a chance to moderate this keynote speech session. And I hope we have already connected with Dr. Kandi. Dr. Kandi, are you around in our Zoom meeting? Because now it's at 4 o'clock in the morning in the European time. Okay, Dr. Kandi. Maybe could the organizer help us to remind Dr. Kandi, perhaps? Is I think he's not still here. maybe we can wait for Dr. Kandi until he is present in our virtual meeting. And I want to, let's say hello to our in-person attendees. Hello, everyone. How are you?
Good.
Yeah, we meet again. All right. So the previous presenter talked about the micro encapsulation. There was a very nice talk about that. Maybe someone who wants to, let's say, pursue study on microencapsulation in that university, in the UITM, for student in our faculty, that will also be great. Miss MC, how is the day in Surabaya?
Today in Surabaya, the weather is very good. After I asked with the secretary, the candidate already joined because Dr. Kandi using another link Zoom.
Yeah, Dr. Gray told this, Kandi will
Yeah.
join soon. I already send the links, the new links.
Okay, thank you, Dr. Hadi, for reminder.
Yes, good morning, Professor Muhammad. Can you hear me?
Yes, very good morning, Dr.
Yeah, yeah,
Kandi. Thank you
yeah,
very
good
much for
morning.
joining us. Yeah. Did you use another link, by the way?
Anyway, so Dr. Hadi helped me to join this one. So I have another link, and
Okay.
finally I'm here.
Okay. Bonjour.
Bonjour.
We are actually at the same time zone at the moment. We are at 4 o'clock in the morning, right?
Yes, I wake up at 3:30 and fresh up and everything. I'm still feeling a little sleepy, but it's fine.
Okay, super. Yeah, Dr. Kandi, in the near future, you can also travel to Vienna. We can meet up together.
Sure, I think maybe last year I came to Vienna for one conference in
Okay.
Boku.
That is my university, you know.
Really?
Yeah, I'm studying in that university at the moment.
Okay, so I came to Boku to attend some conference in the Department of Food Science.
Oh, okay. Did Professor Dietmar Haltri, right?
I don't remember, but some Austrian professors only.
Okay, okay.
He's
I'm familiar with some professors.
I think hopefully so, definitely. So we had a conference in that the conference hall, the newly constructed conference hall. So
Mhm, mhm.
it was good
Okay.
experience visiting the Boku.
Yeah. Unfortunately, at the moment, we did not know each other, right? But in the future, it's
Yeah,
possible
definitely.
to
Yeah,
stay connected.
we can have a good collaboration.
Yeah. All right. Thanks, Dr. Kandi, first of all, for joining us virtually in our present international conference on biotechnology and food science. And dear audience, let me briefly introduce you to our presenter, Dr. Kandi Sridhar. I hope I correctly pronounce it. And he is now one of the researchers in the National Research Institute for Agriculture, Food and the Environment in France. And he is dealing with um, microencapsulation properties of plant protein and novel food product development. And he is also one of the outstanding alumni from the Department of Tropical Agriculture and International Cooperation at National Bingtung University of Science and Technology. For sure, I'm also very proud of me because I'm also graduated from that university. So it was similar to Dr. Kandi and for sure Dr. Hari as well. And he is also one of the outstanding researchers because he has already published more than 90 papers in a very good journal. All right, before without wasting our time, I would like to give chance to Dr. Kandi to present your presentation material for about 45 minutes and followed by 15 minutes for the Q&A. So for the presentation for Dr. Kandi, time is yours.
So thank you, Muhammad, for introducing me, and I thank organizing committee for giving me this opportunity to share my research findings and to interact with so all your researchers from Indonesia. So now I would like to share about my some of my research activities and some of the research that what I'm doing and what are the importance of benefits of the marine systems. So what are the measures that we have to utilize the marine system? So a good welcome to my presentation to everyone. So my topic is centered around so we need to explore the different opportunities so centered around the ocean, and from that we are going to we developed some of the novel functional food products and the nutraceuticals. Since the Indonesia we have a good sources of marine systems, so we need to utilize those systems in order to develop some good functional food products and nutraceutical food products from the marine organisms. So in this session, so I would like to cover some of the sources, marine sources and their availability, and produce them sustainable. So these days we are having a problems with the pollution and we are spoiling the ecosystem. So I'm going to introduce some of the sustainable production technologies. Using these technologies, so how we can extract and how we can utilize the marine system in a better way. And I'm going to introduce a little bit about the marine-based nutraceuticals and their applications in food science. And I'm going to introduce some of the case studies related to the how we are using the marine-based products and their application. And then, so while extracting the bioactive compounds from the marine systems, we also get a lot of waste. Maybe it can be a byproducts or something waste from the marine system. So how we need to utilize the marine waste into the some fruitful way, like maybe development of the food products and some nutraceuticals, etc. And then there is some take-home message and conclusions. So let's come to the the topic. So these days, even me or everyone, so because of our lifestyle changes and we are adapted to the culture like eating some fast foods. So because of changing the lifestyle and we are changing our habits. So if you compare between the old generations and at present generations, so there are a lot of difference of in food products, in consuming the food products. For instance, may take you as an example, taking a breakfast, and is maybe some burger or something else. And because of this, your lifestyle is completely changed. And some people are facing like obesity, some people are facing problems with some health diseases and everything. So these all are because of the change in lifestyle. And you have income to buy some products and immediately prepared products. So because of this, so our physical activity is completely reduced, so that we are getting a lot of diseases. So now if you see this picture, let's see, so there is a shift in the food habits versus health diseases. And previously our ancestors, they used to consume maybe the fruits, vegetables, fresh fruits and vegetables. Now we have moved to the pizza, burger, and some other even chips and something else. So because of this, we are facing some health issues. So in addition to this, our population is also increasing. So if you see last 10 years and at this moment, so our population is increasing up and we don't have the food sources. And there are still some population, they're looking for a one meal at least per day. People, they're wasting the food. If you go to the restaurant and if you don't like some variety of food, what do? You throw it or you left it like that. So there are many people wasting the food and there are many people, they're not getting the waste. So we need to make a alternate plan to feed this growing population through nutraceuticals and by using the marine food products. So now coming to the nutraceuticals, and the role of the nutraceuticals in this present generations, it's improves because of we have a lot of health diseases. It can be a diabetes and blood pressure and cholesterol. You can take it as anything as an example. So we have a many health issues. To overcome these health issues, we need to look for the nutraceuticals. So nutraceuticals have a role to control the diseases. So I'm coming to the term nutraceuticals. These nutraceuticals are basically, it's a combination of the nutrition and the pharmaceuticals. So these are it can be raw food products or fortified food products. So that have some bioactive molecules. So this can improve our health standards. And these nutraceuticals, generally we have two varieties. So which can be traditional one, it's using the direct chemical compounds or probiotic things or enzymes. And traditional one is, these are mostly we are using nowadays as in a research, which are the fortified nutraceuticals and recombinant nutraceuticals. And coming to this nutraceutical market, so these days, if you want to make any business, so I think this is the nutraceuticals is one of the best platform to improve your revenue. So from last 5-10 years, so the revenue is increasing, which indicates there is a good hope for the business with the marine nutraceuticals. And coming to the sources, so if you check about the marine sources, so we have a marine microorganisms, algae, fungi, and seaweed, and sponges, and some of the invertebrates and fish. So by using this is some of the sources of the marine ecosystem. Through this, so we can extract the nutraceuticals, which can be some of them are already working on the bioactive peptides, polysaccharides, proteins, or fatty acids, and phenolic compounds, or it can be any bioactive compound. So these bioactive compounds activity of it can act as an anti-tumor effect, and it can be antioxidant. It can it can stimulate your immunity system and also improve your cardiovascular benefits, and also have an anti-diabetic effect. So any marine based bioactive compounds, it has a very essential activity, so that can improve our health standards. And if you look into the some of the other sources, maybe we have a sponge. So sponge we can extract peptides. So like this, so we have a proteins, polysaccharides, and if you take any marine based system, so we have a rich sources of bioactive compounds. So there are a lot of things. So I worked on the and peptides. So from the marine sources, we extracted the collagen, and this collagen is a major source from the fish, and also from the gelatin we extracted from the fish, and we have a albumin sources from the crustaceans, and we also have a polysaccharides. So we can extract the carrageenan, agar-agar, and chitosan. There are many sources and many major bioactive molecules. So these bioactive molecules, so we can extract and use it for the development of the functional food products. And now, so since the marine sources are rich for the with the different bioactive compounds, and the scientists they develop the different database for the bioactive compounds. So there are many marine based data natural product databases such as a MNCD or MCDB, SWMD, MDDD. So these are the databases. So if you need any product information, any biomolecule information, you just go through the database and have a look to find out the more information on the database. And coming to the sustainable production technologies. So these days, the people are worried about the health as well as the ecosystem. So for this, they want to extract the any bioactive compounds by using the sustainable technologies that cannot harm any, that cannot yield any environmental effect or any, it cannot spoil the ecosystem. So for this, so we are selecting the marine source. It can be any marine source, and what we are doing, we are extracting the compounds, isolating the compounds, and identification. So then we will direct to the marine natural database. So after that, we will go for the, either we can go for the drug, or we can go for the some product development, or you can go for the agriculture applications, or you can go for the some cosmetic applications. So these are the some of the protocol. So that how we extract the bioactive compounds from the marine sources and then their applications. And these are the some of the extraction technologies, some of the more advanced extraction technologies. So that we are using for the extraction of the bioactive compounds from the different marine sources. The combination of the microwave assisted extraction and enzyme assisted extraction, or ultrasound assisted extraction, or supercritical fluid extraction. So by using these technologies, so we are able to produce the high extraction yield, and there is an advantage of time saving. So we can extract more bioactive compounds in a short time, and there is no use of much use of the solvent. And also this analysis will take the very short time, and the extraction efficiency is very high. So by using these technologies, so we can protect our environment, and we can improve the extraction efficiency of the bioactive compounds from the marine sources. So after we extract the bioactive compounds, so first we have to analyze those bioactive compounds and make it the purified compound. Then after that, we identify their structure, and then we will go for the biochemical characterization. So this biochemical characterization is one of the important step to understand the biological activity of the compound. So that can be the toxicity studies and in vivo evaluation studies and other clinical studies. And bioactive compounds. So after we extract the bioactive compounds, so what are the real applications of those bioactive compounds? So generally we work the peptides and some polyphenolic compounds. And whatever the bioactive compounds we extract from the marine sources, so there is a lot of applications for the health perspective. For example, the extracted proteins, it can act as an edible coating for the meat industry. So that is because it has a very rich antioxidant properties and hypertensive properties and anti-skin aging activity. So like this, so many of the bioactive compounds or much of the bioactive compounds that extracted from the marine sources. So they have a lot of food applications. It can be a nutraceutical supplements, and it can contribute to the development of some food products. So it can act as a very active agent in a different health perspectives. For example, it can be anticoagulant, and it will be antiviral activity. So like this, the marine sources. So that's why I call them, it is a treasure. So like undiscovered treasures we have. And coming to the one of the case study that we did a couple of years ago. So we worked on the seaweed. So we worked on the two varieties to improve the drying standards of the seaweed, such as we use the sun drying, we use the oven drying, and the vacuum drying, and the freeze drying after we collect the seaweed. So from this, we discovered it. The oven drying is the one of the cheapest and best technology for the drying of the seaweed. And here we compare the antioxidant activity of the seaweed by using the DPPH and ABTS. So here we it by using the oven drying or the vacuum drying is one of the best technology to improve the antioxidant activity, to minimize the loss of the antioxidant activity. So now I'm going to explain you about some of the marine waste valorization technologies that we used it. So first, for example, if you take the seafood capturing or farming, so are you getting any disturbance from my voice? Hello?
Okay, it's solved already. Okay, thank you.
No, is it okay? My voice is
Yeah,
okay?
it's okay because before someone let's say generates some voices, and it
No,
was
is it from my
interfering
side?
to your speech. Now, no, it was not apparently. And yeah, it's fine with you now. Okay, you
Yes.
can
I'm
continue
thinking,
talking.
yeah, it's my heater, I think. That's why I turn it off.
Mhm.
Okay, so sorry for the disturbance. So now we are going into the how to use the waste, because whatever the marine sources we are using, so we can see the loss of waste generating that in the fish market. You can see, so there is a lot of waste that we are getting. So how to minimize that waste as a scientist, as a technologist. So it's our responsibility to minimize the waste. So for example, if you go for any seafood capturing or any seafood farming industry, so you will see the many you will see the many byproducts. It can be the algae, or maybe some fish or some marine vertebrates. And then if you go to the fish processing and transportation facilities, so there you can see the many products, like primary products. It can be algae, some of the fresher preserved products, and some other processed products, that maybe it can be a cut, minced, or etc. So for the if you go for the secondary processing industries, so by that you can use the secondary processing industry. You can use it for the extraction of the high value byproducts that I explained before. And then during the fermentation, for the fermentation in the marine system, so we can use those uh, uh, materials for the extraction of the bioactive compounds. It can be the chemicals or other biomolecules, and for the energy systems. And whatever the residues we get through the marine system, we can still use the residue for the agriculture fertilizer. And if you look into some of the waste, like we have a fish waste. So from the fish waste, you can take anything, fish, maybe skin or something else. So we can extract some of the valuable byproducts. So by using some of the extraction technologies we are using, like you can use the enzymatic hydrolysis or supercritical fluid extraction. So these are some of the advanced technologies and microwave technology. So by this, you can extract your interested compound. So then we can go for the different technologies, ultrafiltration, nanofiltration, some other gel filtration. Then you can concentrate on the product that you're interested in. It collagen or proteins or biomolecules or oil or enzymes. So this is how utilize the waste. And this is one of our study. So what we did, it's about the Taiwan tilapia skin and its collagen. So what we did, so we took the skin from the Taiwan tilapia fish. So then we removed the skin, then we dried the skin, then we extracted the collagen. So there's two types of collagen. So what we did, acid soluble collagen is the one part, and the other one is the pepsin soluble collagen. And this collagen we want to use it for the healing, for the skin healing, or we also want to develop some of the cosmetic products. And coming to the different functional foods, so what are the foods what we can develop through using this marine ecosystem? And when it coming to the functional foods, so generally any food so that contributes to improve our health standards. So that can be the functional foods, and nutraceutical, so that can prevent and treatment of any kind of disorders other than the anemic. So that is called the nutraceutical. And this functional food market. So if you check on the functional food market, so this is also the very rich markets. So you can earn a lot of money in this by working on by doing the research, and by doing the research and running the industry and the functional food industry. Coming to the how we can develop a food product by using the marine sources. So here I will give you a little example. So how we can develop a food product by using the marine sources. You just select your marine sources, whether it is a waste product or the marine system product. You can select the any sources. So then we have to go for the processing. And after the pre-processing means, if you take the seaweed, for example, so you have to clean the seaweed, and these are some of the pre-processing steps. So then we need to go for the extraction by using some of the extraction technologies. So it can be, we need to sometimes inactivate the enzymes and then go for the hydrolysis and ultrafiltration and separation and the purification. So after that, we need to extract the compound that you are interested in. So for example, maybe polyphenols or proteins, or then we will go for the quality check. After you determine the quality, then you will go for the purification of the compound. Then after the purification, then we can incorporate the compound into some of the food products. So here, if you see the example, so we have selected the marine sources, and then we extracted the compound, and then we purified the compound. So these are some of the compounds that we mostly get it from the marine sources. So after that, we have two options. So one is the dairy-based products. So development of the dairy-based food products, so which is very easy to develop. So, and in the dairy science, so there is a lot of development in fortification of the food products using the marine sources. It can be fermented milk, yogurt, cheese. I think some of the students already, so they're working on the development of some dairy products. And coming to the non-dairy food products, maybe you can go for the fruit juices, pasta, bread. I will one more example about the bread and some other fruit juices. And then we can finally develop the functional food product, so that can be released into the market, and you can earn the money. So now if you look into, these are the marine sources, and then you might definitely have one question. So after we develop the functional food product, so what is the use of these functional food products? So that we are developing from the marine waste or the marine sources. So as I mentioned, so we have a lot of health problems. To work those health problems, so these functional supplements are the functional food products. So that can help us to overcome those diseases, maybe obesity or blood pressure, etc. So these bioactive compounds that we are taken from the marine sources, and we can develop the food product. And so those food products can help to improve our health standards. And these are some of the examples, so that I'm going to quote what are the products that available in the market, or researchers are working on the products. So for example, so they develop the meat, so sausages, for example. So what they use the seaweed. So seaweed is, of course, it's a marine source. They use the seaweed And what is the use of using seaweed in development of the meat product? Because the application of the seaweed, it can improve the calcium rich, and it's a very low sodium and high fiber content. So this can improve our health standards, and there is no problem of incorporation after even we did the consumer studies sensory analysis. So there is no difference between the meat products that is incorporated with seaweed and whatever the meat product that is available in the market. So like this, they also developed some beef patties, and there they incorporated the seaweed. And then what they observed is they observed the cooking time is decreased, and the product looks more soft, and it's more like good technological and sensory and nutritional properties. So by incorporating the seaweed, and this is example of development of the bread. So they use seaweed products, and they develop the bread. The seaweed product that is extracted from the sodium alginate. Sorry, those are the products. The sodium alginate that is extracted from the seaweed, and carrageenan, and these are the products incorporated into the bread, and to see the changes. Now they said that by incorporation of these hydrocolloids, so it can improve it can reduce the moisture content of the bread, and it can reduce the dehydration rate. And also there are many benefits or many achievements by using the seaweed products in the development of the food product. And this is also one another example from Italy. So they developed the spaghetti and some fast food noodles by incorporating the seaweed food products and some other nutraceuticals from the marine base. So now, so although we extract those bioactive compounds and whatever we incorporating into the food product, so we have some problem with the marine based bioactive compounds. So which is nothing but, so if you see any marine based bioactive compounds, so there is a problem associated with the smell. So sometimes maybe the consumers they may not accept the smell. So this is they may dislike the smell. So for that we need to look for some alternative. So which is called the micro encapsulation. So I am working on this micro encapsulation like almost 7 years by encapsulating the bioactive compounds and improving the functional properties. So this will the video will explain about the how we are working on the encapsulation of the fish oil by using the micro encapsulation technology. So this technology we use for the encapsulation of the fish oil and the garlic oil. So we use the fish oil and the combination of the garlic oil. So then we use the soya lecithin. So then after that we mix the ingredients, and we added the sufficient amount of water for the mixing. So and then we develop the coarse emulsion by the blending all the ingredients. So this protein concentrate. So then we did the homogenization for the particle distribution. So then we use the sodium alginate because as a sodium alginate for the encapsulation. So then after we prepare the complete coarse emulsion, so we use this emulsion through our encapsulators, develop one encapsulator, we patented that encapsulator. So this is the calcium chloride solution. So here we use the two systems. One is the dripping method. So another one is the encapsulation technique. So this is the one in the video is the dripping method. So by using this method, so we can develop the small capsules. So these are the some of the after drying. So these are some of the capsules. These are dried microcapsules. So these are some of the varieties of the fish oil or curcumin microcapsules that we developed using the dripping system and some other encapsulation methods. So basically we are using the encapsulation system that our institute only developed in India. So that's the video explains about the encapsulation. So here what we did, so we encapsulated as shown in the video. So then we use the encapsulation and develop the capsules. So after the capsules, what we did, so we incorporated these capsules into the bread. So then we develop the functional bread. Why we need to call a functional bread? Because so we have a fish oil here. So we use the fish oil. It is not only the encapsulation, not only covers the smell, but also covers its biological activity. So those capsules, after we develop these capsules, so there is no any smell of fish oil. Of course, there is no any smell of garlic oil too. So then, so that the people can easily take the bread, so that is rich with the fish oil and the garlic oil. And we also studied the sensory evaluation, that the most of the consumers there accepted the product and said that the product is, it's almost similar to the market bread. And this is also another study we did it from Taiwan. So one of the alumni from the your university, so she worked on the encapsulation of the tuna fish oil by using the arrowroot starch and maltodextrin. So here also we proved it. So the arrowroot starch and maltodextrin combinations can encapsulate the tuna fish oil, and it can extend the shelf life of the microcapsules. And so now we already developed some of the food products, and we need to have some approval from the government. So so every country have a different standards of regulations and laws. So in that case, so Indonesia also to have some specific functional food regulations, and China a health food regulation, Taiwan also health food control act. So through this act, so we can release the whatever the products that we develop into the market. And these are the some of the more specific regulations that are in put into place in Asian countries. So in Indonesia also we have a very specific regulations about the functional food systems, and in Malaysia they do also have, India they do also have. So they have a different regulatory systems to control the release of the functional foods into the market, because some industries they claim that that is a functional food, but it's actually not a functional food. So to control that kind of misleading the consumers, so every country have a specific regulations to control the misconception of the functional food industry. And these are already available functional foods in the markets, like a sea lettuce and chitin and chitosan and abalone and the fish oil. Of course, we all have know the fish oil is been decades available in the market. And these are some of the widely available nutraceuticals and functional food products in the market, the spirulina, chlorella. So mostly we use the seaweed-based nutraceuticals, so that are mostly available as a powder or a tablet. Or we already know that omega-3 oil, if you go to any market, we will get the omega-3 oil and some other compounds. And coming to the take-home message of this presentation is, so as we already experienced, there are many of the microorganisms are their byproducts. So there are very rich sources of many biological active compounds. So and by using this research area, so we can, there is still much to explore for the development of the food products by using the marine sources, and by designing the functional food products by incorporating the marine ingredients. So there are already a successful in the bakery and pasta industry, and nowadays we are also going into the development of the plant-based alternatives. So like plant-based milk, they are also incorporating the seaweed or byproducts of the marine system into the development of the plant-based alternatives. And we are also working on the development of plant-based alternatives like plant-based meat. So by using the seaweed, so seaweed is a good source to mimic the plant-based alternative texture like a plant-based meat or plant-based seaweed product development. So I would like to stress on there is a lot of research. Although we have a good opportunities for the further research in this area, so we still need to investigate the different marine resources for the development of the food ingredients, and then development of the functional foods or the supplements from the marine ingredients. And so these are some of the special issues I am editing. So if I invite everyone to contribute if you are interested for any one of the special issues, and thank you for your attention. So I am now open to some of the questions from audience. Okay, so I think there is no question. So if any questions, so please put thought or raise your hand so that we can communicate each other. So thank you everyone for giving me this opportunity.
All right. Thank you very much, Dr. Kandi, for a very comprehensive presentation. According to your presentation, we have seen a lot of potentials of our Indonesian seawater, because you know that we
Yes.
have 75% of the Indonesian area is water, especially
Yes,
marine water.
I visited Bali a couple of years ago, and it's really it's like undiscovered money we have it. So if you use the sources properly, so we have a lot of we can develop the functional food products or many functional ingredients we can extract from the marine system.
Yeah, because at the moment the fortified food is very famous in Indonesia, because we have already started putting the active compounds, or we can also say sometime functional material into the food product.
Food
So
products,
yeah, we want to also claim that the products sold in Indonesia are also functional. Anyway, I would like to encourage people attending this conference. If you have any question, you can raise your hand via this virtual, or you can also text your questions.
Okay, let's check.
I have seen this one question from KSK Emory. Or I will say Emory, would you like to Dr. Kandi directly, or you prefer I'm reading your question?
Yes, I'm following the chart. So thank you, Emori. So your question is about the challenges for the potential marine derived compounds. So of course, so we have a lot of challenges that in your case, you're working on the sponges. Yes, so there is a lot of challenges for the extraction of the bioactive compounds from the marine systems, because sometimes the extraction efficiency might not be sometimes the extraction efficiency is very low. It can be 2% or 3%. So for that, so these are some of the challenges: extraction efficiency, and their biological activity is not similar as the synthetic compounds. So these are some of the challenges, and to overcome these challenges, to improve the high production, so we can use some of the new technologies like ultrasound or supercritical fluid extraction technologies. So these technologies can improve the extraction efficiency of the bioactive compounds from your sponges or any marine system. And then what technology or ways that currently being done that will help us to process of marine derived compounds to be used in the industry more widely? Yes, so these are some extracts. We need to go for the more advanced extraction technologies like like supercritical fluid extraction, and even the combination of the different extraction technologies. So these technologies can help us to improve the production so that we can further improve the application of the marine food products. So the basically is we need to improve the standards of extraction instruments like ultrasonication or the supercritical fluid extraction, so that we can improve the production, and this production ultimately can lead to the development of the novel food products. So any other question?
Yeah, by the way, Dr. Kandi, it was very interesting to look at your presentation on the microencapsulation, because we know that there are plenty of publications dealing with microencapsulation, especially for the fish oil.
Yes.
In your experience, what is at the moment the best combination or the best formulation of the microencapsulating agent for the fish oil up until now? Because like there are plenty of publication on it, and for sure it is very nice to see what is the best one, or maybe your research was the best one compared to others.
So for the encapsulation of the fish oil, if you go back to the 10 years ago, 15 years ago, so we used sodium alginate. So that is the best. But these days, so we are changing, our thoughts are changing, and people are changing their mind and everything. So they want everything as a plant-based. So plant-based and more non-toxic material. So sodium alginate, it will create some health issues. That's why the people now are going with the plant-based systems, encapsulating agents. So in one of our slide was talking about using the starch. So we use the starch, and these days they are also using the proteins. So if you ask me this question 10 years ago, the sodium alginate is the best. So if you ask me this question now, so some of the plant proteins and the starch, the combination of the plant proteins and the starch is the best for the encapsulation of the fish oil. And when we are talking about the best, which means the encapsulation efficiency must be high. It should be close to the 100%, and the storage stability should be high. So whatever the capsules we encapsulated, it could be stay longer, like maybe 90 days, even more than that. So the combination of these days, the combination of the plant proteins and the starch is the best combination for the encapsulation of the fish oil. And 10 years, 15 years ago, they used the sodium alginate as the best one. But now the people are changing. They need everything more natural and plant-based, no toxic, safe. So now the plant-based systems are the best delivery systems. And I am also presently working on the proteins as a delivery systems.
Yeah.
Yes. Thank you.
Yeah.
Okay.
Yeah, sodium alginate, because you know that we have a lot of resource of the sodium alginate in Indonesia because it is derived from brown algae. Yeah.
Yes.
So yeah, but you are true that maybe we might face the safety of the alginate, because algae in the nature can also play a role as the filter feeder or the phytoremediation. So we really have to be selective to obtain the safest algae for the alginate production. But materials derived from the land can also be alternative instead of alginate. Yeah. Okay. Any other question from other attendees?
Because I want to add one more point for the challenges.
Yes.
And the student asked the question, Emini somewhere. So the selection of the raw material is also a kind of challenge, and it should not be more toxic material. And the complete until we develop the food product. So we need to take care about the safety issues. It can be during the extraction, so we cannot use the organic solvents. We need some more green extraction technologies, so without solvent. And then during purification, we need to go for the more sustainable. So these days, there's a very popular terms like sustainable ecosystem, environment protection, and all these things. So by considering all these factors, so while designing the research experiment or anything, so we need to consider all these parameters. So in order to prove the safety of the extracted compound, whatever the bioactive compounds, through this, by using the green extraction technologies or deep eutectic solvents. We are also using those deep eutectic solvents. So these all are just to provide the green, all natural during the extraction until the food fortification. So these are some of the technologies that we are using to provide the safety and to overcome the challenges. At the end of the day, we need to prove that our product is safe or our compound is safe. So for that, we need to follow all these green extraction technologies or green solvent approaches to claim that your product is safe or your material is safe for consumption.
Okay. Yeah. Yeah, that really makes sense, Dr. Kandi, for the commercializations of the food product for sure, right?
Yeah, for the commercialization of the food product finally.
Yeah, and there are also there have been plenty of companies, especially in Japan and in China, in Australia, they have already commercialized the nutraceuticals and also the extract, right?
Yes, so and the price for the, if you go to the any supermarket and if you ask for the any nutraceuticals, the price is extremely high. So because of they use the more sophisticated technologies for the extraction.
Yes.
And they need to get approval from the different agencies. So that's why all the nutraceuticals, all the functional food products, the price is really very high.
Yes. Yeah. And the efforts should be also very high to get the
Yes.
level of functional
So
food
if you are like for having a discussion, it is nice, like we are extracting the functional foods and all. But when it coming to the reality, so it takes sometimes it takes like years to get the one purified compound, so that can be applied or that can be used in food ingredient in development of the functional foods. It's a time consuming.
Yes. By the way, Dr. Kandi, there is some
Question?
students want to ask question who are in person
Okay.
attendees. Okay, please, anyone want to ask question in the hybrid?
Yes, some raise the.
Yeah, because some people are joining in person.
In person.
Yeah.
Perfect.
Okay.
Okay, good morning. Can you hear my voice? Hello?
Yes,
Hello.
we can.
Yeah, we can. Yeah.
Okay. Thank you very much for the presentation. It's really so interesting. I have two questions to ask Dr. One of which is, you said there is a research that is being made about there's a research that is being made about the skin healing from the shark and other kind of marine. So what I'm asking is, how far is this project or this research? And can you please explain in detail? The second question is, as you said, the population growth is increasing.
Excuse me, may I interrupt?
Okay.
Because I think the first question was unclear. I think because of the microphone issue. So please, organizer, could you help us to fix that?
Can you hear my voice now?
Yes, it's clear. It's perfectly clear.
So the first question is, you said you're making a certain research about skin healing using the skin of
Of the
shark, the other marine.
yes.
So my question is, how far have you gone about this research, and could you try to explain in detail, please? So the second question is, as you said in your explanation from the start, that the population growth is really increasing. So we also having the increase in the pollution. So my question is, my worry is, as the pollution is increasing, the marine is getting to extinction. So from your research, I have not had anything like trying to prevent this pollution or trying to make maybe from the technology trying to increase on the number of marine. So would you please try to explain me how the effect is going to be from this increased demand of the population, which is causing the pollution, which is causing the extinction of the marine? Thank you very much.
Yeah, thank you. So your question,
did you get
yeah.
100%, Dr. Kandi, for the question?
Yes, hopefully the first question is about the skin healing, right?
Yeah, and from the shark, right?
Yes, whatever the marine sources. So it's
Yeah.
about the skin healing.
Mhm.
I hope that's what his question. The second question is about the population is increasing and the marine sources are extending. So how we can overcome this? Yes. So coming to the first one. So the extraction of we basically worked on the extraction of the collagen from the marine sources, and this collagen we can use it for the even we planned for healing, the skin healing, the wound healing actually. So we worked on the rats. So the wound healing efficiency of the collagen that is from the skin. So if it comes to the wound healing, so we have a better wound healing efficiency. We tested on the rats. So we tested on the rats, and the wound healing efficiency is almost like 80%. So that can heal with the using the collagen. So we also it's like almost 3 months or 4 months time for the wound healing, and it has a efficiency to heal the wound properly. And there is also in medical industry they are also using the fish collagen based wound healing system in the medical industry. So there is a high chance for the efficiency to recover the wound healing through by using the collagen from the marine sources. And coming to the second question, I hope it is about the balance between the increasing population and decreasing the marine sources. They're going to be more extinct and all. So for this, what the best approach is, we need to educate the people, because we are the one to create the pollution. The way we are using, if you consider like 100 years ago, the ecosystem is different. Now, if you see the ecosystem, it's completely polluted because of the human activities. So we need to educate the people to reduce the pollution, and we need to go for the using of the waste. So whatever in some cases, in some processing industries or marine industry or any kind of industry, so there should be some byproducts or some waste that must be generated during the processing. So that waste, we should use it, because the population is growing. We cannot extend the land. So we need to look for the sources, so that what we can do. The best sources is, so valorization of the marine sources, or any fruits and vegetable industry or any processing industries. So by using the waste, so that we can at least we can support the ecosystem, and also we can generate our food system, or we can produce our food that can meet the population. So the main 2 points are, we need to minimize the waste generation. The same time, we need to use waste to develop the food products. So this way we can feed the increasing population, at least with some the tasty and good food products. Yeah, thank you.
Yeah, I think one another interesting idea, Dr. Kandi, because in our faculty we have also aquaculture. So to make the resource sustainable, we can also consider the aquaculture or cultivation. So it is actually safer. We can also control the environment. We can also control the nutrient content of the cultivated organisms. Let's say for the fish, we can actually modify the feed if we want to get the meat which is rich of omega-3 fatty acid and extra.
Yes. So here, what we do to improve the nutrient composition for even for the waste or for even any sources, we mostly go for the fermentation. So by using the fermentation, because at the end of the day, we need to have only the biological activity of that specific compound. So we are going for fermentation technology. By using this technology, we can improve the nutritional composition of the material. Like if you take any let's say fish skin or something, then we'll go for the fermentation. So after the fermentation, we will go for the extraction of our compound, so that the activity, the efficient activity will increase. So as you said, to improve the flesh of the things, so that's also one of the best approach to by considering the environmental standards and so more sustainability, of course.
Well, okay. Any other questions, by the way? I have seen someone before raising. Okay, please, Sonia.
Yes, Sonia.
You can ask question.
Thank you for allowing me to ask a question, Doctor and Mr. Muhammad. Good morning from Indonesia, Dr. Kadis Srinda. First of all, thank you very much for Doctor for being here with us. Let me introduce myself. I'm Sonia with finals at number 123 from Fisheries Biotechnology major, Faculty of Fisheries and Marines, Universitas Airlangga, Surabaya. I would like to ask you a question. I've just learned about your lesson today, but highlight from what you said if fortified nutraceuticals will be defined from marine ecosystem and best nutraceuticals with traditional and non-traditional hanging. May I ask, is there any step to make it sustainable? Thank you, Dr. Kandi.
Okay, thank you, Sonia. I hope if I understand the question clearly, so you're talking about the sustainability, how to maintain the sustainability in the whatever the production and extraction and development of the final food product. Yes.
Doctor.
Yes, so thank you. So over the years, so what we are doing, the researchers, so they want to improve the more sustainability. So now they are understanding, because we are getting tsunami, we are getting something, we are getting earthquakes, and we are getting many things. Now the people and the researchers, they realized that, oh, we are doing something bad. So we need to protect our environment. And then they started, we need to reduce our actions. So this way, to improve the more sustainability or to reduce the effect of, even our research has some effect on the environment. So whatever the research activities we are doing, so it has a lot of effect on the environment, and it's releasing a lot of pollution, developing a pollution and a lot of things. So for this, to minimize, even if you're doing some experiment, you're releasing energy through your experiment. So it is like a carbon. So that can again lead to the greenhouse gas. So for this, to make the system as a more sustainable food system, so what we need to do, we need to adapt to the new technologies, such as like as I mentioned, for the extraction. For example, if you take the waste product, so that can be one of the best approach. And after you take the waste product from the marine sources, then you need to select the low processing technology. For example, you cannot very energy consumption instruments. So you can go for the maybe enzymatic hydrolysis or so enzyme extraction system. So this is one of the more sustainable, and you can also use the green extraction solvents. So these solvents can reduce the effect on the environment. So then after that, so when you go for the product development and you try to minimize the use of more processing technologies, this way the carbon print, so the amount of the carbon that is releasing from your instruments or from your system is low. So this way we can maintain the low carbon, and this can support the sustainability. And after we develop the product, so we need to go for the LC analysis. So life cycle assessment. So through this life cycle assessment, so we can know so how much pollution our product is releasing into the environment from the raw material selection until the food product development. So this LC analysis will give you the better idea about how your product is releasing the carbon emission, or how much it is maintaining the sustainability. So by using this LC analysis and by using some of the latest extraction technology and very low processing technologies, so that this way we can maintain the high sustainability so in the food system.
All right. Thank you very much, Dr. Kandi, for the answer. And I think time is up for the session from the Dr. Kandi. So we would like to really appreciate for your time. This is very early morning, I think, in France, same as me
Yes.
in Vienna.
It is.
And yeah, unfortunately, this year we still conduct the conference virtually. So we hope in the near future you can come in person in our university to expand our collaboration.
Yeah, thank you.
Because
Thank you
I
so
know that
much.
your topic is very interesting for us, and it matched to what we have, what we are currently doing in our university in Indonesia, at Universitas Airlangga. All right, I think the Master of Ceremony will virtually give the certificate of appreciation to Dr. Kandi. And for sure, Dr. Kandi, for me, thank you so much again for your participations today. I'm confident that your participation today is very fruitful for our university. Yeah, so we are looking forward to hearing your future contribution to our university. So, as a master of ceremony, let me apologize. Let me apologize if there is something inconvenience about the time and about the technical problem and extra. So for me, thank you. Yeah, please, I will give it back to the master of ceremony.
Thank you so much for our wonderful keynote speaker, Dr. Kandi Srijar, and our moderator, Mr. Goyatul. After this, we will back with Mr. Goyatul. I will give it to Hanesa.
Yeah, thank you, Rahena. The final keynote presentation still be moderated by Mr. Muhammad Nurgoyatul Amin, SCP, MP, MSc. I will give it back to Mr. Goyatul. Your time is yours, sir.
All right. Well, Dr. Kandi, yeah, that was the certificate of appreciation. Have you seen already?
Yes, indeed.
Okay. Thank you so much. And yeah, again, we are looking forward to see you in person in Indonesia, and we are waiting. Let's say we want you to teach us how to prepare the panipuri, which is one of the interesting food from India.
Yeah, sure, definitely. So we will put some of the marine products we can fortify, and we can develop more functional.
Yeah, okay. Thank you.
Okay, so thank you so much.
Have a great day today. Yeah, you're very welcome.
Yes, hopefully. Yeah.
Yeah.
Thank you so much, and have a good day to everyone.
Yeah. Okay. All right, that was the sessions of Dr. Kandi from France. And for the next speaker, we are going to listen the presentation from Dr. Armin, who is one of the researcher from University of Natural Resources and Life Sciences, Vienna. Dr. Armin, are you already here?
Yes, I'm already here. So good morning to everyone.
Okay, vielen Dank. Okay, well, everyone, before Dr. Armin start his presentation, let me briefly introduce you about Dr. Armin. Dr. Armin is one of the full-time researcher in the Institute of Chemistry of Renewable Resources at the Department of Chemistry, University of Natural Resources and Life Sciences, and he recently worked on the utilization of the macrosites for the biodegradable packaging. So it was one of his outstanding work during his research experience. So now we are going to listen and see his presentations on perhaps on the microsites utilization for the biodegradable packaging. So it is very interesting talk for sure, because we are from Indonesia. We have a lot of resource also, which can also be used for the biodegradable packaging material. So please, Dr. Armin, time is yours.
Thank you very much, Muhammad, for the kind introduction, and as well, thank you for having me here on this conference. So I will shortly share my screen. So I will start my presentation. Okay, wait. Where is my Zoom right now? Okay. I hope you see now the right screen. Do you see my presentation?
Yes, we can see it clearly.
Perfect. So then, once more, good morning to everyone, and I'm really excited to talk about my work, what I'm doing here in Austria, in Vienna. So today I named my talk "Rethinking Resource Management: Macrophytes, Untapped Potential for Local Circular Bioeconomy." So maybe, as you know, Austria has no sea access in so far, so we have only sweet water bodies, and we are also looking to utilize this in a proper form, in a more sustainable form. And I think that I will introduce you in the talk a little bit to circular bioeconomy, how we envision it in Austria, and what has this to do with our macrophytes, with our water plants. So macrophytes is the name for water plants in the end. So table of content, like I said, I will shortly make an introduction about our local bioeconomy strategies, especially also in the European Union. It's now very, very often that we have a lot of different strategies from the member states, which is tackling the bioeconomy more. And then also some introduction about the water plants, macrophytes. So this is a big family actually, and what are the specifics. I will talk about the structure of the plant, how we see it. So my background is also material science from the pulp and paper industry. So I made my PhD on this. So I'm really looking every time in material utilization and not actually in food utilization, but I also will discuss this a little bit more. So we came down to the paper production and the products we produced already, the conclusion out of it, and also the outlook, what we are working on it, how we valorize it, such resource stream a little bit more. So then let's start into it. So I want to start with the European framework. Maybe I thought it's not so familiar in your region, but the European Union has called the Green Deal. Green Deal EU. So we are trying to be carbon neutral in 2050. you know, or as well as sustainable and development goals in the end. And we have for every individual member state, we have bioeconomy strategy. So there is really written how we transform our linear fossil-based economy into a nature-based renewable economy. Then what I often point out is the term, we often call it a decarbonization. So we want to decarbonize our energy system, etc. Actually, what we're really trying is we will use in future more carbon. So we will carbonize our economy, but we will defossilate it in the end. So we go back from the fossil carbon, and we will exchange them to renewable carbon. So this is actually how the European Union envision the future economy. And so this has some risk. And the risk is the overutilization of biomass. There are a lot of different talks or something out there, reports out there, which also say, okay, when we want to reach this goal that the European Union will be carbon neutral, then we need a lot of biomass. We need too much biomass. Can we produce it sustainable in the way? And so this inevitably results in a circular economy. So, and for us is then the motivation, okay, we have to use it in a cascadic way, the material. So I wrote here in wood products, in fiber and chemicals, etc. Also, we have to utilize secondary biomass streams. This is in our case then like the macrophytes, so they have no utilization at all right now. Then we have to utilize a carbon management system, CO2 sequestration, or long-lasting products in the end. So this carbon management system is very interesting in the European Union as well. We have a trade regime. So you can buy CO2 certificates for your production process. So the idea behind this is when you somehow put CO2 in the atmosphere, so you get the right to do this, so you have to pay for it. So you have then really a stock exchange for CO2 certificates. And this is now interesting because taking this financing tool into account, you can really make like, okay, you can grow forests, produce CO2 certificates, and they have a value. So you have something to sell there. And so this is interesting to make different economy products out of it. Especially what we think about is when we take now wood as an example. So you grow the wood, you store the CO2 in the wood, you take it out, and you make it then for building houses, skyscrapers or something like this. You really save then the CO2 because this is a long-lasting product, and this will generate then as well this CO2 certificate that you can then sell to other companies like steel mills, paper mills, etc., which have in the production process the problem with the CO2 generation. So in bioenergy for us at the end of the value chain, so this contradicts a little bit these long-lasting products. Building up wood and then burning it directly, so you have the CO2 not stored somehow, so it's really fast. It's really fast used up. So, and this is how we try to envision it a little bit. So I like this. I like this slide. This is a mapping transformation pathways. So give me some sec. I try to give the laser pointer. Yeah, okay. I hope you see now my laser pointer as well. So let me guide you a little bit through this slide. So it reflects a vast opportunity what we can do with residual material. So not only for water plants, but in general. So what you see here, we have blue text fields. This reflects, okay, you can make food feed out of it. We have this yellow text fields. So we have CO2 sinks or long-lasting products, or products production out of carbon, out of renewable carbon. We have energy production. We can make precursors for a bioeconomy. And these green boxes are nature-based solution systems. These are actually technologies already available where you can then treat nutrients, process chemicals, or something like this, air filtering, etc. And I only want to go to the agricultural forestry. So this is the primary production actually, so where we get our food and feed out of it. And then we get some defined organic waste. So one good way to utilize this is every time you make fertilizers, biochar, biochemicals in the end, because soil enrichment, soil enhancement, soil improvement is very important, and we have to look about our soils in the end. So in the last talk I heard as well, so land we cannot grow land. So this is really a limited resource, so we have to protect it in this way. As well, you can then process this in a biotechnology way, so making insects, mushroom, and feed them further, or you can also make then their materials out of it. But with the macrophytes, we go a little bit a different way. What you will see then down there is that we get in a technical chemical processing. So we extract with something, we separate actually our constituents, our chemical constituents, so that we have high value chemicals, we have sugar, protein extracts, and this actually we transfer then into cellulose and fiber and go down to the paper production. So this is actually what the route what we're thinking out. But I think it's really illustrative what you can do everything and how is everything interconnected. So let's go further. How do we assess the pathway? So we have now a residual material, we have different composites in it, and there's this value hierarchy very helpful. So what you see here on the left side is actually the price tag from your product. So the value chain is higher when you go into this field, like medicine and fine chemicals, or food, feed, and ingredients. Then you came down to chemical and materials, transportation, fuels, and heat and power. So the best thing is that we have a cascading use. So you have an input stream, and then you can use it for medicine application. From this rest processes, the rest you use them for food, feed, ingredients. If there is some rest coming, you try to convert it into chemical and materials, and really to look at the carbon what you have harvested is used in different cycles. So normally, when you think it on an economical way, is the amount is also increasing in the other way. So this means that medicine and fine chemicals, you don't need 1 million tons of this. So these are very specific and fine materials what you need there. And you need then, when you say, okay, I want to produce heat and power for people, then I need a lot of amount. And so, and what we know that the biomass is not enough, that we really produce the whole energy what we consume worldwide. And another interesting is the input stream inhomogeneity also increases. So when you think about, you have resources, waste streams, these high amount applications also says, okay, you can have different input streams. So you can put in there wood, grasses, something you find there, and produce heat and power. Biogas production is a common thing to do, because it's very easy to get different input streams there to work in there. There are also some problems, but normally it's easier. For a medicine application, you need a very specific stream, and then the quality should be every time the same. So for this, you have then to think, okay, how I can use my waste stream. I will now shortly introduce you, before we come then to the macrophytes, the other project I'm working on is the Biotransform project, and this is also that we try to introduce value chains for underutilized resources. So the aim in this project shortly is that we provide a route, a transformation route for stakeholders like industries and policymakers, how to accelerate the transition from a linear fossil-based system to a circular bio-based system in the end. And so the main story is there that you need networks. And this is really important. And so these are the partners. So you see we have Finland, Germany, Czech Republic, Austria, Greece, Spain is in there. And there we have then different regions in the end, what we analyze. And this is also important, I thought, as well for this talk. So we have our regions there, like Finland, Germany, Austria. And these are our case study regions. And we try to assess the residual streams, what we have there, on the same way, and give them the same indicators, same pathways, so that we can exchange it throughout the European Union. And so our case study region is the Northern Burgenland. And there we had also, so every case study has its own strength in building up biomass. So there we have a very special lake in this area. There we can produce a lot of reed, which is not, until now also not utilized. And the interesting thing is the transformation, or what do I do with the reed with this water plant in this case is in Northern Burgenland totally different. Like when I go to North Rhine-Westphalia. North Rhine-Westphalia is a very region in Germany with the chemical industry. So I have different processes there. So the same biomass will be transformed in the other way. So only for take-home message in this. And this is actually what I wanted to say. Network is the key. So you're in this to create this. You have to put in there, and this is the focus on this project, that we analyze primary sector. What do we have on residual waste, residual input streams? Also the secondary sector. Secondary sector are the small businesses, are the industries, what they're producing there, what is there, like a bakery or like a carpenter. You have also residual wood biomass in the end, waste, organic waste companies. How does it look like, and can we utilize once more? So this is actually so what we try with workshops, etc. in this field. And what is there interesting, because we have this special lake, and there we have a lot of reed stands which are not utilized in the end. And this is also what we want to bring in with the macrophyte investigation, and that we can transform it into useful materials. And so industrial symbiosis, only for you, is really you develop a network of diverse organization, looking which waste residuals they have and how you can use it in your processes in your local area in the end. So while locally is important, somehow with biomasses will come up later as well. So now this was now the introduction into the bioeconomy, also into the European one, also into the Austrian one, how we try to tackle now the problem and to increase our carbon in the end, and also cycle our carbon in products. And now we go to the macrophytes, and a little bit into the specific topic from Vienna. So macrophytes, like I said, are the water plants, and there is the question: are they useful plants or waste in the end? So you see here that the picture from the Neusiedlsee, what we saw before. So we have these rushes and reeds and beds, and these are actually immersed macrophytes. So they have something of the plant is over the water level. So this is the difference. Then we have here in Vienna, Biophyllum spicatum. This is a submersed water plant. So the whole water body is underwater. And I think this is more related to you. This picture I have from water hyacinths. Also immersed plant, so some parts are immersed, the other one are submersed, and this is how it grows over in a lake in South Africa. And like the macrophytes, like in this example, so they have a really important ecosystem service, so that they're cleaning the water body. And what we have now in Northern Burgenland, the problem is that nobody is using it. So the reed stands are too old, and they're really discussing it if they burn it again, because nobody is harvesting it, because there's no value chain anymore for this resource. And in the 21st century, to burn a lot of hectares of biomass in the wild is not doable anymore. So this is really a bad story. Also, the Biophyllum spicatum cleans also water body, have extractives which prohibited algal blooming. This is why it's actually there. But now it's really, so we especially in Vienna, we really feel now long summers, warmer summers, etc. Now this is really overgrowing. And so they have these nice boats and really cut them down in the ground. So 3-4 meters, they can cut the plant stands down. And they have to do it, otherwise it's not it's going down. So that you have a better picture of it. So general information. So we see here Austria is the capital of Vienna. This is also a Google Maps site from Vienna. There you see this old Danube. There is the main main mowing going on in this action. Also, there's the new Danube that they have also to mow. Why they have to mow is this increasing growth rate, and also this is a very important area actually for the population in Vienna, for recreational boating, bathing, etc. So they don't want to do to have too much plants in this water. So we have 150 hectare, and approximately 4,000 tons per year is harvested only in this area. And yeah, from the quantities I will talk later on a little bit more. Yes, so we have now the general challenges about this resource stream in Vienna. So making a value chain out of it, making a product out of it, talking to industries to cooperate in this field. You have the issue of the seasonal growth. March until October, it's good, but when you think about making paper, making products out of it, pulp and paper industry wants every year the same amount of material. So, and this is easier to get with wood. There you need then seasonal growth means you have to storage it, and storage biomass, you know, there's some degradation going on. You have making a salination or something like this to stable your biomass, and this can get tricky with such a biomass in the end. So necessity of harvesting, I already said, so preservation of the water body, so they should not grow over and kill everything in this stadium. And in Vienna, it's very important for the recreational activities there. And also for land silting, you have also then an issue. If this is overgrown, then the sediment is going down in this area, and then over the decades, you have a land silting in there. Also to maintain a good ecological status. So like I said, we have some issues with this biomass to creating the value chain. So we have this low solid content, only 10 weight% around this when you harvest it. So this means this results in some problems in the transport. So you cannot transport it too far. So production facilities must be in the vicinity. Using this, you have always to think about decentralized production facilities. And when you think about a pulp and paper industry, this is really big factories and not decentralized in this way. And they're producing a lot of material in this way. So storage, I already said the silage is very interesting as well, because it's good when it's not too wet, and silage is a main standard when you have grasses, something like this, and you want to store it over time. So you store it in this time that you have then lactic acid in there, and this reduction in the pH then sees that no mold or something is growing on your biomass. And then also utilization for biogas is also an issue. You can use it. I also have we have some data about this, but you can only put in some amount because it's too wet, and then you change everything. And also for biogas production, the microbes or something are related to a input stream. Like I said, it's a little bit more easier that you put other streams as well, but you have to be careful in this. So now the general availability of water plants. This was also interesting. So sorry, I think I have some problems right now. I don't see my laser pointer anymore. Do you see the Austrian map? Oh, here it is. Now it's working again. Okay.
Yeah, yes, we saw it.
Okay, I don't saw it. Nice. So about challenges, let's talk a little bit more when we say, okay, we want to use the macrophyte, utilize it as packaging, materials, etc. So we don't know the total amount of this biomass actually, because there's no utilization. You only have different fields like this. You see this dot there. These are estimations from newspapers or something like this. Where I read, okay, they harvested something, and because it was overgrown, a lake or something like this. We know it for Vienna, so it's 2,000 tons per year and up to 4,000 tons. We know it for St. Pölten, there we have 70 to 400,000 tons per year. There's also Lake Germany also says something about 100,000, 300. So thinking about paper making, when you know that one pulp, when one industry pulp needs 1 million ton or something like this, you see this is not too much right now, but in the end, we actually don't know it. And then we have here the Lake Neusiedl with the reed stands, and there's also estimation of a sustainable harvesting area about 500,000 tons per year is what would be the available in this. Then we have another lake in Hungary, Lake Balaton is very similar to the Neusiedl lake also. So there's a lot of untapped potential there, and yeah, we hope with our research to get it forward. So like I said, we have the private water bodies, no central harvesting, so we will not really know how much we have. This problem we have also with our woods. We have a lot of private woods, and there we don't know how many woods we can actually really. So it's every time in Austria an estimation in this field. The nice thing is using this biomass, you have no land competition in this field, like when you make agricultural lands or something like this. So you don't need it, and it is not utilized at all. So we should think about how we make it working. So another challenge was with the content, with the wet content. So on the y-axis is the solid content of the water plant, also temperature and the relative humidity. So this was we had to store it outside. We made some little bulks there, and then we sampled over several days to see how it's drying out in which direction. What is interesting is that in the first day you see you have this 10%, then it goes to the second, third day. So the black dots are this upper layer, the surface layer is 6 centimeters around, and the down layer is in the core of this bulk. And after 2 days, we reach this 30%, and this is what you need to really start a good silage. When you have it down there, then other microorganism is growing on your field, and another acid is developed, not the lactic acid, and this makes then a problem. So, and you have to think about, we are in Vienna, so you cannot have tons lying around anywhere. You have not space. You're in an urban space, so you have to transport it somehow. So this is not actually a way to go. So I'm sorry for this. I have some technical issues on my side, I think. I often cannot find my, so now it's going. So it takes the time to load. So we see. Okay. I try to get to the next slide. I see that I have the awaiting thing already. Okay, now it's gray. Oh, Microsoft. Okay. Wait, I think I have to restart it.
Yeah.
So we will.
Do not be stressed, Dr. Alvin. Just take your time.
Okay.
Yeah. We have a technical problem with that.
Okay. That's the first. Oh, No, there's something. He restart already. Wait, let's. Oh, yeah, this looks good. He don't like this slide. Okay. So I hope that I get it somehow. Yeah, but one sec. We will soon continue. Because I don't. This was before as well. So it's really new. Okay. So I try to restart it right now. Come on. Come on. So I restart now the program. Now it's going. So I think you see now my child. He's now older, not so young anymore. So Okay, I restarted it again, and we were there, zack. Shift F5. Do you see the presentation again?
Yes, we do.
Perfect. So, and this is now the water plant we're talking about. This is what growing in the old Danube. So you see the stem of the Myophyllum spicatum. In German, this 1000-blättrige Ehrenblatt. And there is also this bulk material. So it's more when you harvest it, you have a wool of these small water plants in their length, 40 until 200 centimeters, and it grows until 5-meter depth. So this is every time related on the light what's coming down into the water body. So we make then some investigations about this plant. So you see a transverse section. So it's a qualitative investigation about the composition, about the chemical composition of the plant. So on the left side, we use this rhodanine, safranin red and astra blue. Astra blue is reflecting the hemicelluloses and the celluloses from the cell wall, and the other one, the lignins. And why is lignin for us every time interesting? Is because it reflects the recalcitrance from our process. So recalcitrance is how much chemicals do we need actually to utilize then the cellulose in the end. And so cellulose for us is for materials perspective is interesting because it's not so digestible, and we can make our paper and our products out of it, or we go to nanocellulose out of it. We can modify it in 10,000 ways, and this is why we are aiming for this compound. What you see here as well, the black one are the starch coloring, and there is this interesting. So in the cortex, in the center of the plant, there is actually no starch in it. So this also reflects that we have there a suberin layer, and suberin is very famous for cork. Cork trees have this biopolymer in it, and this is why cork is very good for. We have it nowadays for wine bottles to seal them up there, and this is a very good oxygen barrier, and you can find it there as well. So if you can really see on a very qualitative level, okay, which components you will find there, not on a quantitative way, but on a qualitative way. And like I said, we have there the cortex, there's the phloem and xylem, there where the whole nutrients from the plants gets exchanged. We have there a lot. I have not put on my laser pointer. So this is the cortex. There we have then the phloem and xylem, and there we have then the air and humid cells. And there's actually a lot of air in it, so that the plant gets stabilized during the flows in this field. When you look a little bit more, there I talked about this Casparian strip. There is the suberin in there. So this one actually, these are these layers in the cell wall, and there we see a little bit of lignification of this vessel cells there. And this is good. There we know, okay, we can use a greener process compared to wood or something like this, and to have a better imagination how this can look like. I have here a picture from a colleague. It's from a papyrus. It's an immersed water plant. He did the same qualitative quantification of this, and there I see a lot of red. And this I think is good to understand. So this is also there. You know that the stem is over the water level, so that the plant, the cell will have to introduce much more lignin in there. There we have the phloem and xylem, and also then you have very dark red dots there. And this is actually sclerenchyma cells, and this is a highly strengthened fiber cells in the end. And so only by seeing this, you know, okay, you have to adjust your process then in the end that you get then the same results out of there, or that you come really down to the polysaccharide. So in our case, to the cellulose to utilize it. So take another picture. So from the Myophyllum spicatum, the native composition. So we have here the polysaccharides are 45%. There are also the starches in there, the hemicelluloses and celluloses. We have a protein fraction from 13%, a lignin fraction from 70%, also extractives from 12%, and a big ash content. This you have often in residual materials, also in agricultural materials. This is totally different than to to the wood properties where you have mainly cellulose, hemicellulose, and lignin, and that's all. So you have much more complex compound in there. Also, we checked for the heavy metals compound. There I highlighted the lead, the PB, because this reflects that it's not eatable from the Austrian law or for European law, it's not eatable. So the threshold is too high, but you could use it as animal feed. But nevertheless, animal feed also, I was discussing with some scientists about feeding, and there's also, it's too wet. So you have to think about drying, pressing it in pre-advanced, silage it, something like this. And this I showed you before, to have it back in mind. Okay, you cannot left it there anywhere in Vienna, so you have to transport it or think about it. So this is not the way to go for our biomass in this field. So we also make some biogas application trials with this. Here you see the degradation kinetics. So it was ended, or we reached the peak after 7 days. And on the right side, you see the specific methane yield. And also, so we have the peak there at 7 days around, and then we are below 160 liter CH4 per kilogram. And this is not so much. So when you have other plants, agricultural plants, you can go up until 300. So to have a feeling about this value. But it's doable. And if you have a biogas plant and say, okay, it's the way to go. This is what I wanted to say in advance. It's always depending on your local situation, actually. So, and then different routes are possible, and different routes make more sense in the end. So paper production, how does it look like for the macrophyte? So I mapped it out really bit. So paper production is a very old process already. So we have this harvesting. This is done from the municipality of Vienna. Then we have the washing step in there. We cut it down actually to smaller parts, and then we cook it in our process. And this is then the interesting thing when you have low lignin content, because the cooking, so the digestion looks really different, or the fractionation than there. So we have the normal soda pulping, and we also bleached somehow also with peroxides. And the interesting thing is that we only have 80 degrees. In this field, we took 4 hours, so we played a lot with the optimization of this process. We'll come down later to this, and this is very, very interesting, because you can really go down with temperature, go down with time, and also come to the cellulose. But this comes with a price. So this recalcitrants, this lower recalcitrants comes also with a price, because we have to mix our paper. Then you get out of this your cellulose fibers. We mix them then with a wood pulp, actually, because you will later see on the mechanical properties what does this mean when we have a pure myophyllum spicatum pulp, so pure water blend pulp for paper production, and we made then composites out of it with long fibers, drainage, and then we came to this paper. So this, you see this brownish you have after normal soda pulping, you get this brownish color. And then with bleaching, you get more into a yellow color. So the grammage from our papers was 80 gram per square meter. We made these pure myophyllum pulps, and these are the MPs. And then we made this mixture with 60% of this myophyllum pulp and with a normal kraft pulp from the paper industry. Let's talk about fibers. So how does fibers look like in the end for us? So the microscopy illustration. So there we have the kraft pulp. So these are the wood fibers. Nicely, also highly fibrillated. You see in this small scale there. And then we have this myophyllum pulp. And there you see you have these sort of fibers. So these are actually parenchyma cells put together and making some residual material. And there you see a small fiber. So this means for us is every time interesting the aspect ratio, which means the length to the diameter. This should be very great. Then you know that these are long fibers, and then this is more than a particle-like structure. So, and this means, and this results then in different mechanical properties. There you see the stripes we had from this different paper. How does it look like? So this kraft pulp was not bleached. The mixture were done this brownish, because the kraft pulp was also not bleached in this way, and the soda pulps very brownish. So there are scanning electron microscopy picture. We also have the graph pulp. There you see as well this structure, what the fiber is making in the paper. And then we have this 100% myofilm pulp in this field. There we see as well this parenchyma cell, also a very closed surface in the end. And also what we find there was interesting. So these are the mixtures, the composites in there. You see then this cooperation with fiber and this other bulky material. So this myofilm picatum pulp, and we also find then so diatoms, which are silica based small not bacteria, but small microorganisms, small algae, which are on the paper. So with the soda pulping, you would need a different to get rid of them. But they didn't make anything. But it's nice to see this kind of things. So then we make tensile tests. There now we have the 100 kp. So the wood pulp, 100%. So it's out of long fiber. It's a very highly fibrillated pulp. So we have a very good specific tensile strength in there with around 70. And then we have here this 100 myofilm pulp bleached, and also then the composites. And you really see that bleaching also gives them more access to the cellulose. So there we have an increase in the tensile strength, and this is a good strength. So we didn't expect that it's better like wood, but it's sufficient. I have the other slide as well for this. And also with the composite, we could improve then our mechanical properties in this way. Specific modulus of elasticity, they are nearly the same. So they are also very good values. And the most problematic thing is about the elongation at break, so the rigidity. So, and this is where the aspect ratio comes into play. So with lower aspect ratio, we reduce our rigidity. This can make then in the end some issues in the process. And when you think about the paper making process, so you have dynamical forces as well in this machine, and there a long elongation at break helps you that it gets not teared down during the process. So, but this is expected. What you have when you take such kind of, and then you have to adapt your production process in the end. And here we have the tensile strength and elongation curves as well. You see there we have the paper from only graph pulp and then from the myofilm pulps. But it's really, we have good values, good strength values as well with reduced elongation. But this you can change as well with other biopolymers like starch or resins or something like this. So this is a work in progress actually to improve this. But now we also tried to change the cooking. So, and there we have autohydrolysis and acidic pulping. Autohydrolysis is actually hot water extraction in the end. So you try to utilize your hemicellulose that you get also acidic pH range, and then you cook it in a digester under pressure in a pressurized vessel. And there you see as well, you have this black coloring. There's the soda pulping we were talking before. There is the peracetic acid in different concentrations, and this is nice. You have acidic pulping. You can bleach in one step with this kind. Yeah.
Apologize, Dr. Armin. You have 3 minutes left for the presentation.
How much?
3 minutes.
Oh, okay. So then I have to speed a little bit up. Sorry. Okay, and this is actually what we are working currently right on. So to improve our cooking, and there you see it in the papers as well how it looks like, and there you see the rigidity really good. So this is a pure soda pulping, and there you see really how it's cutting out. And there we made them paper with 70% of this myofilm pulp and 30% of wood pulp. And there you see this is getting nicer paper out of it. And also when you use this peracetic acid, you're getting in white, but also you have a thing of rigidity. This you also see there in the mechanical properties. Only shot there. I took now a normal office paper that you have there, the strength line of a normal office paper. Now we have the myofilm pulp the soda pulping 100%, but we know the rigidity problem, but the strength is very good actually. Then we can mix it together. And there we see the acidic pulping, where we see this jump there. So where you really see you need a sort of a concentration, otherwise it's not really good working. So the process was the same, but then with the 35% weight percent of the acidic acid regarding to the biomass, then we have to jump in there, and then it's getting better. But really, there's somewhere the threshold in the end. So, and this is also what we see, the nicely correlation between yield and mechanical properties. So we know that we have our polysaccharide fraction in there. And so we also, when you pulp, you see then the yield in the end. So when it goes down, you see, okay, I have my cellulose there, and then I get the good values out of it. And when the yield is not going down, it will be not so good. But okay, this is also expected because then I have lignin protein extractives in there. And this is the main message in there, because I have to pulp until 50%, something like this. What do I do with the rest of the 50%? So in a sustainable way. So this is what we have to think about this. Shortly, some applications, what we did there. We have this paper packaging, also printing. We did already also composites with the company. This you can buy already. So this is on the market. But they are not functionalized materials. This is functionalized. This is not functionalized in there in this way. So also we have some things this we can. So short for the conclusion, care is good for the biomass. Climate change and eutrophication. This is why we have to mow it, why it's so overgrowing. Then also that the biomass is underutilized, and that we can make paper products out of it. But then we have to think about the special processing afterwards, and we need a holistic biomass fractionation, because we have 40% not used already right now. This is also what we're working on, and this I want to show with this one. This is the outlook. So we already discussed about energy production, food feed production, why we don't do it, heavy metals, etc. We utilize the fibers already. Next step is extractives and proteins. And by doing so, we want to use the residues for fertilizer. This is why also we try this with the peracetic acid, because the processed chemicals are no issue in the end. And these are the paper products. So we can also make furniture out of it, so that we make some plates. But the proteins, we now try then to utilize as glue. And like I said, the antioxidants are in the extractives. This we will also look in the future. So process optimization, this already said. Other water feeds, additional water plant feedstock. So this potamogeton crispus is also coming now in the new Danube, is overwhelming everything. So this we will also have a look in the future with the municipality of Vienna, and there we will do a lot of further characterization and this process optimization. So really to use the proteins as well. So this is very important. And this is where I'm coming now back to the industrial symbiosis. This is now our group, we are together. So maybe most of the companies are not familiar to us, but to you, but this is the municipality Berger, the producer of the boats. Then the Bocal Jimeno is also with this nature-based solution system, cleaning process water with plants. And the Lansing maybe is common. They're producing fibers, and this and these are all together right now. And there we try to really increase the value chain. And this is the hard work actually, as well as a scientist, to bring them all together. So you have to really talk to them. Hey, the process has to look like this. End of life management has to look like this, etc., etc. And so I come to my end already. So if you have some water plants, and I know that you have a lot of water here, since we are always looking for new feed stuff and input stuff, and I found a lot of literature, water hyacinth, what you can do when you go to cellulose, when you go to nanocellulose, you're going to this biocomposites or paper making. This is more like what I presented, but like the supercapacitors, controlled drug release, that you make hydrogels out of it, etc. So there's a lot of opportunities to do. And so now I'm really finished, and thank you for your attention, and I'm looking forward for the discussion.
Okay, thank you very much, Dr. Armin, for a very comprehensive presentation. So for the next session, I would like to open for the question and answer. So I will invite everyone attending this virtual conference to ask any question. And for your information, Dr. Armin, there are also some people attending via hybrids. They are now in person in our faculty. They are summer school student from some countries. So this, we want to show you that we are really open to those who are interested in visiting our university for such program, summer course. Anyway. So, any question from this one? There is one question from Mutiara Alia. Let me read the question, Dr. Armin. Good afternoon, Dr. Armin. My name is Mutiara. I would like to ask a question regarding the utilization of macrophytes. How can the utilization of macrophyte contribute to sustainable paper production? And what are the environmental benefits of this approach within the context of the local bioeconomy? Thank you.
Thank you for this nice question. So yeah, so we have the lot of discussion what we do with our wood. So nowadays paper is produced out of woods, and the main issue is the recalcitrance. So wood, the process is much higher from the energy demand. So from the cooking, so you're over 120, 30 degrees. You're in a pressurized vessel, etc. So you need more energy to go to this to the cellulose from the wood. The other thing is our wood resources are getting scarce. I said as well that we want to build now our buildings out of wood, etc. So now everything relies on the wood, and you are somehow limited in a sustainable harvesting our wood resources. And so therefore we are looking for additional input streams, like then we can make this composition. And so to replace 70% of the wood fibers and only have 30 or 20%, so we can optimize this. This is also a sustainable way in this way. And as well, we have to, it's really that we don't do anything with the macrophytes right now. So they are mowed, and then they are composted in this way. And we have to look at cascading, sinking, utilization, and then in the end we can compost it anyhow, or we burn it in a waste incineration plant. This is so the idea.
Yeah. So Dr. Armin, like how many percent what is the progress of the utilization of macrophytes in Austria so far? I mean, like, are people have already, let's say, exploited this species, this commodity?
No, nothing. It's really in the infant. It's really, you have to discuss a lot to do this, and it's now it's seen more, in my feeling, critical. So more okay, can we really and they didn't realize the potential right now. As well with the reed. So reed is when you talk about macrophytes and also the reed stands, there was so you make this thatched roof. This was a very old cultural tradition, so that you have roof materials is somehow lost, and but it's coming back. You really see the change. So this project I showed you before, this biotransform project, is really see there's different thinking, and yeah. So, and we hope therefore for network building corporations.
Okay. Any another question, by the way? There is someone raising her hand. She is Miss Mega Permata. Would you like to ask question by yourself?
Okay. Hello, Dr. Armin Winter. Good afternoon from Indonesia. I'm so sorry, mister. I didn't activate the camera. Let me introduce myself. I'm Mega Permata from Fisheries Biotechnology at Airlangga University. Okay, I would like to ask about general challenge microbiota. From the material that has been presented regarding the general challenge of microbiota, one of them is necessity of harvesting. How to prevent these challenges?
Thank you for the opportunity.
Did you get the
Thank you.
question, Dr. Armin?
About harvesting, not entirely. Can you repeat once more?
Yeah, would you like to repeat your question because we cannot clearly hear your voice, Mega?
Okay. I would like to ask about general challenge microfiche. From the metro, there has been research regarding the general challenge of microfiche. One of them is necessity of harvesting. How to prevent this challenge?
How to prevent this challenge? I understand.
Yeah.
Okay.
Yeah, you mean like harvest? I mean, like the challenge how to harvest it, or yeah, maybe that was your question.
Yes.
Mm-hmm.
Yeah. Okay. I mean,
Yes.
if I can understand, it's about the challenge of the utilization in the general, Dr. Armin, including one of the harvesting step, I think.
Yes.
Right.
I try. So I will also talk a little bit about the general challenges and also harvesting. Or maybe we have to go a little bit back into time. So these macrophytes were in the old Danube. So this is a native plant. There every time we're in the Danube already. And in the 90s, this water was highly polluted with cyanobacteria. And this plant have the extractives to get rid of the cyanobacteria. So it was a good idea to plant them in there. And then beginning with 2004, actually, then this exploded. This stance was not so the issue, but you really could see it. And then with 2005-06, they started to harvesting it. And harvesting is, in terms of sustainable thinking, it's I think a really quite excessive thing. So you need a lot of energy in the harvesting because you have boats, and then you harvest a very wet plant in the end. So several thousand tons, but they're very wet. And this is somehow, I think they now have a good thing with it. When you look to America, there are a lot of reports, scientific reports out there. They have also this Myophyllum spicatum in there, but it's not native. And this is the only way you can do it, really, to cut them down. So they also try with other species to a little bit of battle to grow over the other stand, but it's not working right now. So you really have this harvesting issue, and with the harvesting issue, you have then this wet material. Then you have the transport issue. You cannot transport it too much because then it's too costly. And this is what we tackle as well with the. This is where we see the opportunity with the process. I could not show too much from the process we are envision it, but it should be then a decentralized process. And this is what we want to develop with the Berkeley company, also with the harvesting, with the boat producing company, that you can really utilize it decentralized, and you make the first transformation, let's say, into cellulose, and this you transport. Then you don't have this issue anymore.
Yeah. Okay. It is very interesting, Dr. Armin, when you talk about that. In Indonesia, we have water hyacinth, which is abundantly growing in many rivers in Indonesia. And now I know the reason why people just dry the water hyacinths just next to the river. So next to the river, there are a lot of dried water hyacinths. Now I know the reason why they did not separately proceed it. I mean, like they quickly proceeded just next to the harvesting area, right? No,
but this is very interesting.
Not what they did is plausible. Now I understand.
Yeah, why they did it? Yeah, but it's really in Vienna, it's not allowed. So there's really the trucks are there.
Yeah,
this
I
is
know.
coming there, zack, and then they're going. And this is the problem. They also said you cannot press it near the water body. Like you said, when you press it, then the whole, also the cells get distracted, and actually the protein. So the nutrients go out of this water, and then you have it in the water again openly. Then you have the growth.
Yeah.
And so this is really an issue. And so
That
also in
there's
the
really
process,
strict regulation.
you need it, and also this is
Yeah.
important with the process. When you say, okay, you go to the cellulose, then you have this fertilizer. And we also have a think about, because it's a very liquid fertilizer, how we want to treat then the wastewater and have then an effluent free of nutrients, so that you can really make it decentralized on the site, and then you can flow it again. And so this is the, but this is actually what we discuss with the companies. I cannot say there too much right now. So this will be in the next years then.
Okay.
So
basically the research, let's say, the study is still ongoing, right?
It's still ongoing,
Okay.
exactly.
Yeah, on the pen state. All right, Dr. Armin, thank you so much for your time this very early morning in Austria time. And yeah, this year the conference is still conducted virtually. So we hope next year we can conduct this conference in person, or in the near future, we also expect that you can come to visit us in Indonesia to expand our cooperation, because let's say considering to the utilization of the macrophytes in Austria, which is abundantly growing in the freshwater in Austria, so we can consider to optimize the utilizations of the water hyacinths in Indonesia. Maybe those who are not familiar with water hyacinth, I would like to say in bahasa Indonesia is enceng gondok. Yeah, we say it enceng gondok, Dr. Armin.
Okay.
Okay, before I close this session, I would like to give the certificate of appreciation for Dr. Armin, for the Master of Ceremony or operator. Would you like to help me to show the certificate on the screen? Okay, Dr. Amin, we virtually give this certificate of appreciation to you.
Thank you. Thank you very much.
We will think about sending this. Do you need the printed certificate? That will be great. So yeah, we will think about sending the printed certificate to Austria. We will think about that. But will you prefer getting the printed or just the online document, Dr. Armin?
Oh, printed would be also nice.
Okay. Let's say it is really a stem from Indonesia.
Yeah.
All right. On behalf of Faculty of Fisheries and Marine of Universitas Airlangga, I would like to thank you all very much for Dr. Armin for the contribution, for the fruitful contribution in this very early morning in Austria time. Again, we want you to, let's say, think about the expanding the cooperation in the future. By the way, for your information, guys, please attend this year. Dr. Armin is already have already shown off in our official YouTube video, so you can access in our YouTube channel in our faculty. So Dr. Armin has briefly described about the microsite utilization of Austria. All right, have a great time today, Dr. Armin. And I know that Austria now is getting colder and colder. And before I close, would you like to give us, let's say, a brief statement for our student, maybe motivation?
Yeah, for sure. So really thank you for really look forward to this talk, and also thank you, Mohammed, to inviting me to this as well when it's so early. And so what can I say? If you're interested, so we are every time looking for corporations. So really also for students who are highly motivated to work on this field. So on resource utilization, sustainability issues. So really get in contact with us. So the book is very open and looking forward to this. And yeah, then I hope that next year we can see in personal. So this is much better than like online.
Yeah, sure. But you did your best, I'm sure. All right. Again, have a great time, Dr. Armin. We are looking forward to seeing you again in person in Indonesia in the near future.
Thank you very
Okay.
much. You also. Bye-bye.
Okay, then I give it back to the Master of Ceremony. Thank you.
Yes, thank you very much to our amazing keynote speaker and of course our moderator, Dr. Armin and Mr. Koyatul. We would like to thanks for all the excellencies of our keynote speakers, which is Professor Dr. Zaibunisa Abdul Hayil, Dr. Kandi Sidhar, and Dr. Armin Winter. And also our moderator, Mr. Anur Ahadi Abdillah, SPI, MSI, PhD, and Mr. Muhammad Nur Goyatul Amin, SCP, MP, MSc.
Ladies and gentlemen, now we are going to have a break time. While having a break, we will also present posters from our participant. We will be very pleased to have all audience to have a look at the posters being presented later. To be noted, after the break, there will be oral presentations by our speakers that will be started at 1 p.m. Therefore, we expect all participants to be here again at 12:45 sharp. Now, please enjoy your break time and see you all later.
Attention to all the participants. Our event will start in 5 minutes. Before we start back to our event, let us remind you about the guideline for the 4th InCoBIFS 2023. Don't forget to mark your attendance for the conference.
For the guidelines in InCoBIFS 2023 Zoom meeting, number 1, access to Zoom will be open 1 hour before the event starts. It is not mandatory, but please include the InCoBIFS logo in your presentation. Download and use our virtual background. Wear office or formal attire. Please mute your microphone when listening to the lecture, except when asking questions. During the Q&A session, if you have any questions, please use the chat and raise hand functions. The moderator will unmute to allow you to speak. The presenter must turn on the camera during the presentation session for the presenter. Change your name to presentation number, name, affiliation. For general participants, change your name to name and affiliation. The moderator or co-moderator will remind you when the presentation time will end. Before we start back to our event, don't forget to mark your attendance for the conference on meeting chat.
Good afternoon, ladies and gentlemen. Welcome back to InCoBIFS 2023. For your information, the room for invited speaker and oral presentation will be divided into 2 breakout rooms. There will be room 1, we have the Fisheries Biotechnology topic with smart indicator film as freshness indicator of shrimp product tema. For our invited speaker, Mr. Anur Ahadi Abdillah, SBI MSI PhD, with Safa Aisyah as the moderator. For the oral presenter, this room for presenter number 753 until 762. For room number 2, we have fishery product processing and engineering with valorization and seafood bycatch and byproduct as functional food and food enzyme fermentation topic with our invited speaker, Mr. Heru Pranomo, SPI, and Biotech, PhD, with Harry Prasetyoning Tias as the moderator. For the oral presentation, the oral presenter in this room for number 768 until 793. The breakout room is already open. Please choose your own breakout room for each topic that you interest. Our operator will help you if you feel trouble as long as your name already has the specified format. Let me repeat. For your information, the room for invited speaker and oral presentation will be divided into 2 breakout rooms. There will be, in room 1, we have Fisheries Biotechnology topic with Smart Indicator Film as freshness indicator of shrimp product tema from our invited speaker, Mr. Anur Ahadi Abdillah, SPI MSI PhD, with Safa Aisyah as the moderator. For the oral presenter, this room is for presenter number 753 until 760. For the presenter number 753 until 762. For the room number 2, we have fishery product processing and engineering with valorization and seafood bycatch and byproduct as functional food and food enzyme fermentation topic. This topic will be briefed from our invited speaker, Mr. Heru Pranomo, SPI and Biotech, PhD. The moderator will be Mrs. Harry Prasetyoning Tias, and for the oral presenter, this room is for presenter number 768 until 793. The breakout room is already open. Please choose your own breakout room for each topic that you are interested. Our operator will help you if you feel trouble as long your name already has the specified format. Thank you. Okay, sir, we will ask the operator to help you. Thank you.
Let me remind you again, the breakout room is already open. Please choose your own breakout room for each topic that you are interested, or our operator will help you if you feel trouble as long your name already as the specified format. Thank you.
Let me remind you again, the room for invited speaker and oral presentation will be divided into two breakout rooms. There will be in room 1, we have Fisheries Biotechnology topic with smart indicator film as freshness indicator of stream product from our invited speaker, Mr. Anur Ahadi Abdillah, SPI, MSI, PhD, with Safa Aisyah as the moderator. For the oral presenter, this room is for presenter number 753 until 762. Room number 2, we have Fisheries Product Processing and Engineering with valorization of seafood bycatch and byproduct as functional food and food enzyme fermentation. From our invited speaker, Mr. Heru Pramono, SPIM Biotech PhD, with Ms. Eri President Diaz as the moderator. The oral presenter in this room is for presenter number 768 until 793. The breakout room is already open. Please choose your own breakout room for each topic that you are interested. Our operator will help you if you feel trouble as long your name already has the specified format. Thank you.
Welcome back, ladies and gentlemen. We are going to the next agenda that we've been waiting for, which is a wording session. In this session, we will announce every best speakers for every topic and one best poster. Without wasting any time, let's start the wording session.
Okay, the first award is for the best presenter on Fisheries Biotechnology topic, with the title of Molecular Identification of Nemacillus sp from Bangka Island, Indonesia, based on the cytochrome oxidate subunit 1 gene. The winner is Mr. Yordi Aprianto. Sorry, committee, the certificate doesn't open yet. Okay, again, congratulations to Mr. Yodi Aprianto for your amazing presentation. Okay, next, for the best presenter on fishery product processing and engineering topic, with the title Optimasi Bioplastik dan Komposit Griselor Kitosan, Sisik Ikan Mujair Erecromis Mozambicus sebagai alternatif plastik komersial. The winner is Miss Riza Nurmalita. Yes, once again, congratulations to Miss Riza for your excellent presentation. Okay, and the last but not least, the winner of the best poster is nominated to, congratulations to Aska Askia Akbar, Laila Lutfia, and Dwita Nirmala for the poster tema, The Effect of Maltodextrin Addition on Powder Flavor Quality of Faname Shrimp Head Boiling Water. Once again, thank you and congratulations with the winner.
Once more, congratulations to the best presenters and poster creator. And to all of you who has not been nominated, keep your heads up to the sky and keep believing in yourself. There is always another chance.
For the closing remark, we invite the Vice Dean of Research and International Cooperation of Faculty of Fisheries and Marine, Universitas Airlangga, Dr. Engineer Sabto Adriono, SPIMT. This remark also mark an end to this fourth international conference on biotechnology science 2023. To Dr. Sabto, time is yours.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone, and thank you so much for being here. First of all, Honorable Dean, Faculty of Fisheries and Marine, and then Vice Dean, lecturers, and also students will join this conference. This is the fourth InCoBIFS, which annually conducted by Faculty of Fisheries and Marine. I also deliver gratitude to all participants, which from morning and afternoon still join this program. And also I believe from this presenter, they share many information and also new findings from research and many activities regarding to the biotechnology and also food science. And thank you so much for all committee member. MC was stay until this afternoon, and hopefully this program will be have meaningful and beneficial for us. Give a new insight in the biotechnology and food science sector, and hopefully we can meet again next year in the fifth InCoBIFS, and I hope you can share this information to your colleague in your home university or your country. Thank you so much for the MC, and officially I close this conference with say Alhamdulillah. Thank you so much, and back to the MC.
Alhamdulillah. Thank you so much to Dr. Sabto with the closing remark being end. Also marks our end to this fourth international conference on biotechnology and food science 2023.
As the Master of Ceremony, we would also like to say thank you for your participation and willingness to be here from the very first start until now. To be noted by all participants, the certificate will be sent to your email personally by our committee very soon. I hope that we all had mesmerizing experience today, and we are sorry for any inconvenience that we unintentionally made. It was such a beautiful experience for us to be the master of ceremony to all of you, and we very much hope to see you again at the 5th InCoBIFS 2024.
Don't forget to mark your attendance for the conference. And I am Hangesa and Raihana. Say goodbye and Assalamualaikum warahmatullahi wabarakatuh.
Good afternoon. Have a nice day.
Thank you so much, Hangesa and Raihana, and also all committee member on the back stage. Thank you so much. Thank you so much also all participants. Hope to see you again. Bye. Bye-bye.
Thank you so much, sir.